What the? That's not right. That's what should have happened. What is happening with my stuff? What is happening with my stuff? Hi! I love the way the cheese slice slaps.
Oh, now you can't see it! Why did you do that? No!
Cheese.
Caseri.
Cheese.
Shaking my head.
Cheese.
Hello.
Cheese.
Hi! I think I'm here somewhere. I hear the slaps. Wait. Look at the top. The little cheese flap. Amazing. Welcome! Welcome Spike, welcome Lyre, welcome Bell, welcome Buzz, welcome Cheese, Christopher, hi, Omni, welcome, Omni, Myriad, Elfie Faye, hi,
Cheese.
Lyre, Christopher, okay, hi, amazing.
Hello. Hi.
Shop.
Now the voice effect is worn off. I've already finished greeting everybody, so no one could make out what the hell I was saying anyway. Hi!
Delicious plastic
They're all just building up precisely on top of each other. They're not going to behave any differently. Man. I guess I could slide to the side for you. However I do that. How do I fucking... there we are. Sorry about that outburst. I just forgot how my thing works for a sec. Minor outburst! Also, hi, welcome, Linted. Hi, how are you doing? There you go, look, it's slightly different now. I can rotate as well. Sorry, I'm breaking your arm. Thank you for the pad slayer. I could do with those right now. Covered in cheese. Ah! Okay, I guess that's gonna help remove the cheese. Hello, hi. It's me, it's a...
Sue.
It's a 2D day right now because like the way it zooms out, you can just see that it's this little 2D plane. Hey!
Cheese.
Why? I'm not that spooky. Welcome Amy Pie as well. Hi, thank you for the... Wait, I'll catch up on the redeems in 1 sec. I'm slightly doing a thing. More invisibly than usual. It's a 2D day today because we need the webcam to have a look at the stuff that I'm doing on a breadboard. It's going to be some breadboarding going on today's stream. So webcam cannot be looking at my face. So yeah, I have a grand total of 1 webcam, and yeah, it's not looking at me. Anyway, well, hands. They'll be looking at my hands. Gloved, of course. Sheesh. Yeah, mine's out of the gutter. Do you think I was just gonna show bare hands on Twitch? What, I wanna be banned? Anyway. Hello, hi, welcome. Cheese board day? Kind of. I'm almost ready. I'm almost ready. I'm sure, I guess I'm ready. Maybe, possibly. Who knows? Probably not. Why is this music so loud? Chill just a little bit. Vichy. Alright. Hi, welcome. Wait, you can secretly a bear? Shh, don't tell anyone. Wait, this particular strand of hair says don't tell anyone. But it's mostly forehead, actually. Oh, God. Hold on, let me catch up. Where are the redeems? Where are they? Hey!
Cheese.
Okay, fine. Thank you for the pats, Myriad. Catching up. There's the hydration from Vance. Thank you. I'll do that right now. Actually, I need to right now because look how hot my room is. Oh, wait, you can't because I'm wide. Yes. The urge to eat is strong, but there is no way. True, because that would mess up my my thing. I like the way when I go, it looks like I'm going with my mouth. Hi Sleepy, welcome. Definitely not bare hands. Yeah, no, not the bare hands. as bannable. How do I feel? Very tired. But I also kind of want to like actually do something. I've been wanting to actually do something for this particular thing for like a couple of days and stuff. Nyan. But yeah, welcome. Hi, sorry. I should probably go to a more interesting view immediately, shouldn't I? Because like, why would anyone want to be looking at this all the time? Wow, look at those. I just had a look at that email that you sent Umi Pie. Thank you. Like, not for the cheese, Belgian. And thank you, Ericsson, as well. Oh my goodness, so many pads. And pass and lion, yes. That's a lot of pads. That's a lot of nuts. I just looked at the email you sent Umi. Those are some nice, sharp teeth. Cheese board day. We need a webcam fund for the webcat. I actually did want to get a GoPro for partially due to the fact that it can be used as a webcam, but mostly for other reasons. But the webcam will be a benefit as well. Mostly because it can do a high frame rate of 240 FPS sustained. Then I discovered that it actually can't focus very close. So if I wanted to do close-up stuff, then I would need to... Obviously, I can't do 240 FPS as a webcam. But if I wanted to do close-up stuff, then I would need to get some little Chinese lens thing, because there's no official lens thing for it, except for the 13, I guess. But the 13 is really expensive. Anyway, hashtag not sponsored. Hashtag I don't even have a fucking GoPro. Oof. I actually ordered a new camera this weekend so I could stop using my phone. I see. For secret reasons. A little bit secret. Just a little bit. The really wide FOV is super nice as well, because this camera is super tight FOV. Yeah. Holy Mother Mary. Uke in 2D, I know! Hi, Lotus. Welcome. Maybe if I eat my monitor, will the uke fly? Try it, I dare you! No, don't try it. Don't try it. Thank you for the pants. Okay, I'm gonna press the button now. Boop! Ta-da! It's low resolution thingy as well, because I'm scared whenever there's anything mildly reflective in the thing, so low resolution makes it less likely that I'll accidentally dox myself. Anyway. So, yeah, behold. Hang on. Let me just properly apply these way too long trademark flappy uke gloves, where for some reason... Oh my goodness, what is that? Oh, there's like a hole in it. It's a hole. There's like this thing here at the top of this finger. There's like a hole there. It's like maybe it touched like the soldering iron or something? Because it looks like slightly burned, and then it's made a small hole. Wow, these gloves didn't last very long, huh? I mean, it's me. I'm the problem. Why is this? There we go. Holy flickering interface. The hole is where your hand goes into the mute. No, not that hole. My hand isn't that small. How am I gonna fit through there? Jeez, not even a long uke could fit through there. We've got to hide the uke selfies forever, lest someone die of a cute attack. Die of a cringe attack, more like... Got him. Ignore that thing that appeared for a moment. Oh god, you can't ignore that! What is happening here? Oh, I see. Thank you for the pants, Spray Rider. Hi. Show my hand. This is what I mean about having an FOV that's not wide enough. This is as much as you can see. You can just see fingers. Woo! That's how you got your pokers in there. Not through that hole, it's not. Pair races? Oh, nice. Not that kind. Not that kind. That's clever, though. That's clever. All of the fingers have holes in them. Look, stop. I actually ordered a new web. Oh, I already read that one. Okay, I think I've caught up then. I'm going to college soon. Any tips, y'all? No. I pulled out of college, so I'm probably like one of the worst people to ask, to be honest. Yuga's wearing gloves because she secretly has robot hands. Shh, 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 shh. Jeez, Myriad. Thought I could trust you. That's why I made you a mod. God. Anyway, I mean, no, it's just Nova, right? Nova's the robot. Okay, so, what I want to do on today's stream is take this Arduino, which is not really an Arduino, but I mean, well, it kind of is. It's like it's open source or whatever, but it's, as I said, it's Elegoo. Really elegant slime. Elegant goo. Look at that. So elegant. And, so yeah, this is going to be, I'm just gonna, like, use this to output a, something that resembles this over here. With like a thing pulsing really quickly at like 62.5 kilohertz, and then this one's just going on and off slower. And this one could, like, yeah, whatever. Anyway, to approximate, because the Arduino doesn't actually have an analog output, is the thing. So this is a way to approximate a an analog output. And you can see this. We're running like in slow motion here, obviously, because this is not 62 kilohertz, is it? And you can see the waveforms being made roughly. You can see
I
when
saw a guy throwing milk and cheese and butter at people who walked by. I thought to myself, how dairy.
Oh, wow, she said that so well. Nice. Congrats. I forgot I even had that sound on there. Congrats. Good job. I approve. This is me trying to do a thumbs up. You got the thumbs up. You got the what? You got the speech of approval from RoboYuke as well. She didn't let you down. Pulsar check. Thank you. Hi, Sexolotl as well. Sexolotl, sorry. Has been checked. So you can see when this one turns on here, the pulsing is allowed through, and that's pulling the waveform down. And then when it turns off, the waveform's going back up. Obviously, it's going to be happening much faster, way faster than this even. So yeah, but it's not going to do anything until I've made this little circuit in real life. So I'm about to try to make it. I showed this on stream recently. Basically, this is a speaker, so we can kind of zoom in past all this mess, and this is the Arduino, so we can zoom in past that mess as well. And this right here is really what I actually want to be putting on the circuit board, so on the breadboard. What? Hi, well, welcome, Dan? Question mark? I'm not sure if pun based on something I said or something else. I'm gonna pretend that I said something that allowed that pun to happen, and that it's not just a strange first message that needs to be deleted. I found a fully functional LeapPad Ultimate, and I'm gonna mod it. LeapPad Ultimate. LeapPad. What is a LeapPad? It's reminding me of, like, there was like a line of children's toys called, what was it? Is that what it was? LeapPad? Was it Leapfrog or something like that? Thank you very much for the follow, Pretty. Welcome. Or Pudding, right? Pretty. So yeah, let's put something on this damn thing, shall we?
Jeez.
Ah, Smithers. Hello, Smithers. You are really good at turning me on. Wait, what is that? That must be a Simpsons quote. I don't really remember that though. What the hell? I can almost imagine it. Oh yeah, man. Can you tell I haven't been able to sleep that well? I can almost imagine it being spoken in the voice though. It's when Smithers turns on his computer with Lisa watching. Oh! That's funny. Oh, it's Burns' voice clips. Oh, okay. Mr. Burns. Made by VTech. Oh, VTech! That's it, okay. Yeah, I do remember them then. White and green themed, right? I think my brother had one when he was young. Man, that was a missed opportunity to, like, open it up and see what was going on inside. This one is pink? Holy. Alright, let's get some components out. So, transistors are here. Behold. I mean, I've got to get it out first, it's not quite coming out. Ah! There we are. Oh my goodness. Okay. Okay. Behold my drawer of transistor-like things. Basically, electronic switch-related things. I think these are Hall effect sensors. Anyway, this is what I want. One of these, and one of these. We have here the... Well, I'm not sure which is which, actually, but... Well, it'll be whichever one this is not. PNP, apparently. Are these ones. This is not written by me, this is written by the seller. And then, I guess they're in PN. Anyway, I should probably get the datasheets of this out. There's some MOSFETs in there as well. A whole load of them, in fact. I just need one of each. And I'm gonna need one capacitor as well. Well, one... two capacitors. I was about to say one electrolytic and one blah 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 blah, but no. So I'm assuming that this is actually going to be fine, because like this is always positively charged. Like current is flowing into it from positive to negative, and then it's flowing back out, obviously. But like this side is always on the positive side, so this should be fine, right? To use a polarized capacitor here. And same here, like this is always the positively charged side, even though sometimes the capacitor is charging in and then sometimes charging out, so... I hope so. We'll see. You'll see a pop live on stream if it's not okay with it, I guess. Maybe if my monitor is broken, I'll eat it to see if the uke will fly anyhow. No, don't do that! It's not that I'd eat, but... that I'd fly a box of little junction friends. Yeah! Did I say hi, nymph? Hi, nymph. I'm not sure if I said it. I hope so. If not... Nymph! Hi. Welcome. I don't want to be hearing this right now. I don't know why. I don't want to be hearing... Do I want to be hearing this? I do like this song. Sure, definitely. Fine. I'm very quiet, Volenia. You didn't, and I'll remember forever. No! Alright, where are the datasheets? Where are my datasheets at? Here we are. Oh, this is not going to be shown on stream very well. I didn't plan this out. I guess I could do this. Yeah, it's fine. Okay, so BT337 is NPN. Okay. So, where are we? Where's my flipping simulation? Here we are. So at the top we have PNP, and then here we have NPN. Alright, so from the Arduino, you know what? First, let's get some power onto the board. So I'm gonna take some wires. And I can have, you know, something to go by. Alright, here's a black one. Here's a red one. I'll just take it from the Arduino. World's most expensive power supply. It's nowhere near the world's most expensive power supply. I don't even know why I said that. Anyway, let me just connect red. And black. To 5 volts and ground. Obviously on the original. So, sorry, on the final thing. Which should be arriving tomorrow, by the way. The actual microcontrollers that I'm going to be using for the Pet Long Yeek project should be arriving tomorrow. Obviously, I'll believe that when it happens, because, you know, it's rare that something actually arrives when it's meant to arrive, but, anyway, when it does, it's going to be 3.3 volts and not 5, but whatever. Hey, Xegrist! Welcome! Second wave, kind of. I hope your day is as beautiful as you always are. Hey, what the? Stop this. No, you. Shush. No, you. I guess I will just do it this way. We'll put red in there. We'll put black in there. It's rare that I actually use these these power rails. What the fuck is wrong with me today? Anyway. Piano rails. Oh, maybe it's like piano rolls is what I was thinking of. Okay. And I can just pull power from there, wherever I need it. It looks like I actually only need the power at 2 points though, so... Maybe it's a little pointless having them go in there, but whatever. Alright, let's start putting some stuff on the board. Let me look at the pin out between the NPN and the PNP, which is this one. Thanks for the follow, Rick. Welcome, welcome. And hi, F Mega as well. Greetings to you as well. Hoi. Can I control page up to switch between tabs? I cannot. I've only been using this viewer for like most of my life. I can't. Most of it's slight exaggeration probably, but for as long as I can remember anyway. Which is also not saying much because I can't remember what I did like 5 minutes ago. Anyway, where are we? Okay, 1, 2, 3. 1, 2, 3. Why is it scrolling me to the side when I'm switching back, but only on this view? What the fuck? Oh, this one stays scrolled right. This one scrolls left. Excuse me? Squeeze me? Why? Is it to do with the scrolling method, even though they're both set to the same thing? Have I just discovered a bug? What if I close this one and load the NPN one? Is it like always the one on the left one that gets scrolled back? Okay. There. Huh! It doesn't do it now. What the fuck was all that about? Very strange. Anyway, how does every stream turn into an impromptu bug finding stream / fixing stream? I don't know. It's got a decent sized ARM processor. Looks like it would love some kind of heatsink. What? The leap pad thing? Also a funny bug. Aww! It's a cute bug. Wait. Pat. I'm patting it with my floppy fingertip. Using an entire Arduino just for the 7805. Is that the power regulator? The voltage regulator? I'm going to be using it to generate some pulse width modulated stuff as well. Looking Doohoo's server. I'll do that after stream. A bit of Linux tossed at it, a touch of Steam on it, and see what it... What? You're gonna try to run Linux on like a children's toy thingy? Well, I guess it's not what I was imagining. The thing I'm imagining is like running on an LCD. Not dissimilar to the one that I'm gonna be using. I'm just gonna be using a much smaller one. Alright, PNP transistor. Give me one of those. Give me one of those. I'll be able to look at the screen and see you followed in a minute. Right now I'm struggling to pick anything up with these stupid white gloves on. Okay, there we are. Once again, these gloves are not because I need them to handle electronics or anything, it's just... I need them for streaming. Hashtag just VTuber things. Thank you for the follow, Woogie Face. 705. Okay, so this one is BC327. I doubt that you can read that. Although maybe, if I change a thing, you'll be able to read it. Oh, I think this is very promising. Let's see. Hold. Oh my god, you can read it! Look at that! There you go, BC327. So that's this one, the PNP. I wonder if you can see the other one through the bag as well. Probably not. It's very hard to see through the bag. Add the markings. Yeah, whatever. Anyway, they should be 337. Yoink. Why is it doing the thing where it goes past the ideal focus again? Sure. Question mark. Question mark? Something like that. Alright, so PNP, right, let's have a look. So what I actually need compared to this, let's get these both on the screen at the same time. So PNP is at the top, right? Yes, the arrow is going inwards. So that's the emitter, which is pin 3. So 5 volts needs to go into this one. The pin that's at the right side of the flat edge, when the flat edge is close to me. That's where 5 volts goes. Okay, let's do that. Which way around should I put this? I think it'd be easier if I actually rotate this, which is not great for viewing on the camera, but What if I do this? What if we put it there? Yeah, then the 5 volts can go. Yeah, okay. Alright, so 5 volts is on the right when viewed this way. So let's just start building it in roughly the middle of the breadboard. If I can get this to go in. Yeah, man. Spread your legs! How long until I get banned on Twitch? Oh my god. Please! Why is like the middle leg fracturing longer? It's catching on the hole. Okay, there we are. Get in there. So I want 5 volts there, and actually that's the only place I need 5 volts. So I'm just gonna put it directly onto that row. And in the middle is the base, because a sane person designed this transistor, thankfully. And we need a 1K resistor into that. Okay, do I have any... I have a few resistors lying on my desk because I pulled them out of the little programmer thingy that I ended up making on stream the other day. I think these might be 1K. I have never been bothered to learn the resistor color codes. So I'm going to measure to be sure. Let's find out. Let's find out. Maybe I could even get this on screen.
Event sub session reconnects. Disposing of old web socket.
Is it gonna work?
Event sub connecting. Event sub successfully connected. Now entering receive loop.
I wonder if it actually worked. Okay, this is the very first time that that's been triggered. I sent up this notification when I was working on porting over my streaming setup to use the new Twitch event sub rather than pub sub, which is not that new, but they deprecated pub sub, so it looks like it's worked. Let me just test if an event comes through. Hold on. Nah, it doesn't. Thought it'd be a bit too good to be true. Okay, it's time for me to close my streaming setup and reload it then. Yeah, I don't know why that doesn't happen. Did I resend the requests for listening?
Event sub connecting. Event sub success.
Shut up, Rebiuk. Now it should work. Ah!
Jeez.
Yeah, it does work. Thanks for testing. Alright. Can I get this in view? No, that's ridiculous. I cannot get this in view properly. See, imagine if I had a wide angle lens. You can see the camera in the reflection there at least. Alright, are these 1K? Our survey says we've got the leads in the wrong things. Thank God I wasn't trying to measure voltage. What is that? The fuck? It works. It does work now. Hi, Fallen Charlotte. Welcome. Thank you for testing it as well. Absolutely just testing it. Okay, it's a 20k resistor. What the hell? Why do I even have a 20k resistor? I don't remember using one of those. This one is 1k though. That's what I need. Okay. No, not okay, but 1k. What the? I'm measuring another one. This is not even in view. I'm wondering if I have like some 1k ones with their leads already trimmed. That's the thing, because that way I can, not have giant resistors. Who cares? It's a prototype. Just get the thing working, Uke. I was worrying about snipping the leads down so that it looked more sensible, but no, we'll just have giant ass resistor leads. Alright, 1k. So let's put this in. Let's add it. 1k. Let's bring that over to... you know what? Let's bring that over to the other side, actually. I think I'll bring that over to the other side. Or I could... I'm just thinking in advance planning, because the two 1k resistors are going to need to connect to each other, but then also the resistor things are going to need to connect to the transistor things are going to need to connect to each other. So I feel like this could be done neatly if I were careful. Am I careful though? That's the question. I am... screw it, I'm trimming these resistor leads down. They've still got little bits of stickiness at the end. I don't wanna goop up my breadboard more than it already probably is. Thank you for the follow, Rochman, or Rogone. It's snipping time. Are you ready to snip? You don't have to be, because I'm gonna do it. Behold. Snip. And snip. Now it doesn't have the sticky stuff anymore, and they're like a sensible length. Sadly, I don't have my bin next to me, so I have to put these legs somewhere else on my desk. There's not much space on my desk right now. Cellular automata, wire world. Those are words, indeed. Hi, cool coding cat. Welcome, welcome. I don't know what they mean. I mean, isn't cellular automata like John Conway's Game of Life, wasn't it? I'm gonna shove this further up still. Yeah, we'll do it this way. Actually, you know what? I'll get both transistors in first. Let's get both transistors in first. Then I'll see where I can fit the resistors. Having them come down to this side of the breadboard will be fine. Seems like a bit of a waste. I usually try to squeeze everything as close as it can be because I always end up growing the circuits and I want as much space as I can. Man, this is just meant to be a simple thing. Surely I'll keep it simple this time, right? We won't end up with where is it? With this again, right? Surely. I can't easily show this on stream. What the f? What the f? Hold. No, Explorer, I don't want extra large thumbnails. There we are. Surely it won't end up like this. Won't end up like this again. There we are. I finally got it in view. Maybe I need like a tiny monitor, just a monitor running at a low resolution that is actually the entire thing that's on the left side of the screen here, rather than just cropping my window down and having nothing on the right side of my screen here, where you can't see my mouse pointer, because that's where my webcam is. Anyway, next one is 337, and I'm gonna do a sanity test. Nope, I failed it. I'm not sane. Ha 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 ha. Okay. So the right leg is the... Well, this one is the emitter, and the emitter goes to ground, and that is the right side. Okay, so I'm gonna need the transistor the other way around for that. The other way around. Because here I've flipped it. This component. The arrow is like on this leg here, but it's on this leg here. That's because I just flipped one of them vertically, but to flip this vertically on the breadboard, I need to like rotate it this way around, so let's do that. This is hard for me to even see, let alone for you to see. Oh, it went in much more easily. Look at that. There we are. They're like sharing a row there. Is that visible? I think it's visible. If I can tweak that focus slightly better. Yeah, that might be better. Not that you can see the legs from this angle anyway. We kind of need the camera to be looking head on almost. Or like at a 45, you know, downwards, but also forwards. 8 gigabytes of... Okay, this is a very different thing to what I remember. It was like a toy laptop. The thing is meant to look like a laptop. That's the thing that I remember from being a child. Okay, so ground will go there, and 5 volts will go there. And this actually looks kind of neat. Let's just do a sanity check. That the right-hand side, the left-hand side of this one, left-hand side of this one. Oh my god, left hand is what's being viewed from this side there. So the right-hand side, when viewed from this side, is lead 1, which is the side without the arrow, which is the collector. And that is that side, and it is connected to this lead. Okay, nice. So the output of this is gonna... You know what? I'll put this stuff on this side of the breadboard. And I'll put this stuff on this side of the breadboard. That shouldn't be difficult to do. So we need this 1K resistor. It's more than 1 second has passed, so I don't have any faith in my memory that this is the one that was the 1K. Okay, yes it was. This is the one that was 1K. Sponsored by Arduino? Nah. Oh wait, that should be hidden. Yeah, sorry, it's not sponsored by Arduino. I was doing Arduino stuff last time, so I had that thing. I've never been sponsored by anyone. No one cool has wanted to sponsor my streams so far, so... Man, this is difficult to do with these stupid gloves. I might need to do this off screen. Kind of want to make that span a wide distance. It was unnecessarily wide. That'll do. I need one more 1K resistor. Which, I think this might be? Let me measure. Did I play Turing Complete? I've never heard of that as a game. This one is 1K. But welcome in, Mavi Gokyu? Mavi Gokyu's here. Gonna snip the ends of this one as well, because these leads are a little sticky and there's stuff sticking to them. Which is how I can tell that they're sticky. Also the fact that they're now sticking to my glove. All one of them are sticking to my glove. Makes them easy to pick up though. It doesn't make them easy to put down. Did it... Is it off me? Where'd it go? Oh, okay, it's on my desk. I'm just blind. Nah, I usually try to put the logo up there though, for what I'm currently doing. Multiple times I've forgotten to make the logo though, and... yeah. End up doing it during the starting soon screen. Really cutting things close. Thank you for the follow, Mavi. Oh my goodness.
Stream sponsorship.
Thank you. Thank you very much, Linted. Man, Linted is cool. I'd happily be sponsored by Linted. Linted does electronic stuff as well. Linted is the first VTuber that I saw doing electronic stuff. I thought I'd be the first, but then I realized, oh no, Linted's already doing it. I'm sure there have been many small ones in the past as well that went unnoticed. Okay, so the middle pin, base. Sorry.
Base.
Of both is coming up and ending on column 13 there. Why is... oh, wait, that's a poem. I was about to read your message. Hold on,
Why is Carl Lightwood's cousin near her paws?
Wait, hang on, let me restart that. Sorry, I was speaking over.
Why is Carl Lightwood's cousin near her paws? As Yuki builds without the paws, it becomes first crisp and neat, then maybe a boop, soft and sweet.
We'll see.
The breadboard hums, the circuit sings tiny tones from tiny things. She taps the code, adjusts the loop. This cat's on track for beep and boop.
That's good. I like that one. Okay, nice. I can put this away now. No, wait, no, I can't. I'm going to need to measure one more thing. Or a couple, actually. Okay, so here's where we put in our signal. Also, hold on a second. Hang on a second. It just occurred to me. These are not the transistors I will be using originally. They are just the only, like, NPN and PNP transistors that I have, I think. BJT ones. I've got a whole load of MOSFETs. But not BJTs, so... Is the switching speed even up to this? Like, it needs to be switching at 62.5 kilohertz. What is the switching speed? Okay, how does this bandwidth product thing work again? It's like the gain multiplied by the bandwidth is equal to 260, right? This is in the megahertz, so this must... Okay, so if we're putting in no, how many milliamps will we be putting in? Like, probably 5 milliamps. Or, yeah, 5 milliamps, I think. It's not going to be that high eventually. I'm just doing this because reasons. So then it's going to be turning this 1 milliamp into, if I remember rightly, about 50 milliamps at most here. No, that's not where I should be measuring the current. Or maybe it is. I'm not sure. Wait, why is this going so slowly? So reading that number at the bottom. 30, 30, 40, 30. Okay, so it's roughly a gain of 10. Thank you for the follow, Scarlett Hassan as well. Welcome, welcome. Okay, so in that case, the maximum speed we'd be able to switch at with a gain of 10 would be 260 megahertz divided by 10, right? Which is 26 megahertz, which is still far, 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 far above the 62.5 kilohertz that I need. Okay, I don't think I need to worry about the speed of these transistors. I also don't know if I've used bandwidth product correctly. I only recently learned what bandwidth product even means, and so that's the first ever time I've tried to use it, so I might not even be using the value wrongly. Rightly. I may well be using it wrongly. A humming breadboard seems like a not good thing. True, I nearly interrupted, but then I thought, nah. I nearly interrupted to say, I hope not. But then I thought better of interrupting. And didn't. Nyan. What am I doing now? Where's the thingy? Here it is. Nope, that is not the thingy. Here it is. Okay, so alright, we need one more wire from the Arduino. It needs to be a PWM pin as well, so I think it was gonna be pin, was it pin 11 that Talkie used by default? If I want to just use this with Talkie eventually. Talkie being the library that decodes the speech and stuff. Right now it's modified into a state where it doesn't work. So wait, no, I mean it is, but it's not much to make it work. I'm pretty sure it was pin 11 or 9 that it output on. Let's have a look. Talkie. Come here, notepad, my beloved. Oh, 3! Never mind, pin 3. Only a little bit off. Oh yeah, right. Sorry, I was looking in the wrong section. Oh my god. Thank you for the follow 8 upon a time. I was looking at this wrongly. I thought that I was looking at this section instead of this section. This section is the one that can do PWM. Can it do PWM on all those pins, or I can do it on the... Oh, PWM on the ones that have the little, like, tilde dash kind of thingy. Of which 3 is 1, and 9 is 1, and 11 is 1. Okay, so I'm not being too crazy. Alright, we need one more color. Let's take this one. It's purple. Pin 3. Pin 3. 0, 1, 2, 3. You know it, you love it. 3. This is far gonna reach. Just about. And that's gonna go into those resistors. It's not very grippy. It just sort of pulls right out. It's very unsatisfying. Look at that. Oh yeah, never mind. It's this command. Hope it's gonna make a good enough connection. That's my concern. Yeah, it just about reaches. Bit of a stretch, but... Okay, so these transistors one of them should like pull current into this middle pin, and one of them should push current out of it, kind of, or push current into and pull out of. But right now I've got nothing going on here, so how about we actually take that current. Okay, so this one is limiting the charging speed because at worst Well, let's just see. Once this starts discharging and when the sine wave starts going down, that's when the most current is going to be flowing, I think. Because it's basically going to be short-circuiting this transistor. When this transistor turns on, it's basically going to short out this capacitor to force it to discharge, and there it goes. We're seeing spikes of 160 milliamps there while it's discharging. Sheesh. Isn't this kind of wasteful? We're like discharging and then we're having to charge it straight back up again. I have seen some people like put a low pass filter here as well to basically smooth the signals into the transistors, and this would probably work with these transistors, but I don't know if that would work with a MOSFET. I'm gonna try it. This might be an incredibly inefficient circuit, but whatever. These transistors are rated for 800 milliamps continuous, and this is like 165 pulsing, so it's probably okay. I mean, I'm sure it'll be okay, but it's not very efficient, is it? Maybe I can mess around with it if this works at all and see if, you know, adding things makes it better. The first micro... Oh, by the way, eventually I'm going to need to change this. Like, I'm going to want another transistor up here that's feeding into this one. Basically just like this, but up here. And there's going to be a separate pin. And this transistor is going to turn... Wait, is that going to work? I'm hoping that I can switch this 5 volts off, basically, sometimes. So this entire circuit becomes unpowered. Yeah, because by default, when this pin is low, it's... Wait, are pins set to input by default? I think pins are set to input mode by default, right? So this will be floating by default, actually. So what I could do is very, very, very weakly pull it high, but then it's constantly draining current, which is stupid if this entire circuit needs to be off. I just want to like cut power to the entire flipping circuit by default. Eventually, to save power on the little pet long uke thingy. But for now it's fine. For now it's fine. Yeah. Alright, so we need a value of 22 in this circuit. I don't know if that's actually necessary. This is going to be driving the speaker not too hard. If I'm calculating this correctly, which I may well not be, then that's like roughly 40 milliamps going through here at peak. A little bit less. If it were 40 milliamps and it's 5 volts, then it would be 0.2 watts. And the speaker that I have, which one should I use? I have 3 that are like basically the same. 1, 2, 3. And they're 0.5 watts. I think they're all 0.5 watts. That one's 0.5 watts. This one is 0.5 watts. And that one is 0.5 watts. Okay, they're all 0.5 watts. 5 watts. Okay, I'll use this one. It's already got wires attached to it. And I'm lazy. It's also really dusty. Okay, I'll use that. I need a resistor as well. And before these wires like snap off the terminals, I need to solder them anyway. I was actually expecting to have to solder them. I didn't realize I had one with wires on them, so it's a little bonus. Okay, 22 ohms. Da-da! Da-da! Also, hi King Cybersnail! The first microcontroller I used was a PIC and ASM, and the first program I did on that, I counted on an 8-bit integer that was mapped to pins to make a counter in binary. Neat! Neat! I'm gonna be resorting to super simple stuff like that eventually as well, once I get the new microcontrollers, because, yeah, it's a kind that I've never used before, the STM32. And so, Yeah, I'm probably gonna have to start from basics. I'll do something like that to verify that I'm accessing the registers correctly, I guess. And the ports correctly. Well, I guess also just, yeah, toggling a pin would work. I don't need to be counting. I can't monitor many pins at once is the thing. I can't monitor... I don't have an oscilloscope with 8 channels, so I can't monitor that. I have a logic analyzer that was a very cheap clone of something else. Not cheap one. But that's very temperamental because it's a cheap clone. At this point, I wish I remembered more of my electronics lab class. The final project was a simple RC car. That's so cool! That's cool! Like actually using, you know, not just like a microcontroller, like an Arduino, but using like dedicated ICs. Oh, this is kind of annoying actually. I need these resistor legs to get underneath these resistor legs. That's not very good. Let me trim down these legs a little bit more on the one that I'm about to insert to make sure the resistor can sit like really neatly down on the breadboard. And we don't get any fun short circuit surprises. Yeah, so it's here where the 2 resistors legs touch, transistors legs touch, need to come over to this side of the breadboard. Okay, I'm about to flipping just take off these gloves and do it off stream. Let's... Other than that... Let's also try not to cut this resistor in half. There we are. Nice. Wait, I put it in the wrong side. I put it in the wrong hole. I need to do 18, not 17. There we are. Are these anti-static gloves? No, they're secret VTuber gloves. They come with a special hole that got burned by me sometime. Not sure when. Actually, I don't think it was burned. I think it was like weirdly snipped. Maybe it was snipped with like dirty cutters or something. Okay, so alright, we've done this, and this. Now we need capacitors, and then the speaker, and then a little bit of code. Okay, capacitors. Look, do you like this drawer that I put together? It has the... Oh my god, I need to move this out of the way. Hold on. Ah, move. It has these values written. I like printed those and then like hot glued them into these little dividers. And there's like hot glue running along the bottom as well. That. I put my hand on this so it didn't fall out. Hi Birchish, welcome. Hi Dara, gloves, those are just supports. True. Hi Dara, incognito gloves. Yeah, pretty much. I'm gonna posture check. Posture has been checked. It's quite a few capacitors, but these are not only a single value though. This is like everything that ranges from larger than or equal to 1 to less than 10. So there's like 3 different values in each one, I think. And right now we're looking for 47 microfarads and 10 microfarads. Here's one. It's 10 and it has short leads. Perfect! Now we need 47. Accidentally killed the 3v3 regulator of the Arduino nanoboard. No! Posture check. Oh my god. Can I slap that thing with cheese? I don't have cheese on hand. I can slap it with a capacitor. Capacitor. There you go. I guess I could drop it. Capacitor. Ah!
Cheese.
We're gonna have a redeem where it's throw a capacitor at me, and then we have to have people recording the capacitor voice. And it'll be like different languages as well, so we'll have like condensator or something, however you pronounce it in other languages. I know some languages call them that. Maybe connecting a capacitor with 100 microfarads, 25 volts, with 25 volts on it wasn't a good idea. Maybe. Oh my god, that poor thing. It's like, regulate this! Zap. I missed a thing. I only have an AAS 2-year degree in software engineering. We had basically an electronics... what the hell? We had basic assembly. My brain merged basic assembly into the word basically. Amazing. This is the message I'm reading, that one. And electronics with IC chips and breadboards, analog wave generators. But it was enough to figure out how to scavenge monitors and other devices by switching out burnt capacitors, etc. Please be careful with monitors. CRTs are scary. I used to trash pick flat screens and rebuild them. Oh, right. Maybe I'm showing my age when I was assuming a CRT when you're talking about a monitor. Right. Never mind. Yeah. Never mind, yeah. LCDs, of course. Of course. An Arduino, and we use a Bluetooth app to control it. Oh, okay. I see. This. What's the software on the left? It is... let me give you a link to it. Hold on. Wait, it's actually the correct window, but I need another window to be able to get the link. Hold on. It is... Where is it? Oh, there it is. So it's available as a website, which is this. There's also a link to standalone offline versions down here. So I'm just running it locally. It's a flipping Electron thing when you download it, because of course it is. Unfortunately, but you know. CRTs are really scary. Yes. Okay, I'm gonna chop off this one's legs as well. This is the 47 microfarad. Same size, physically, but not capacity-wise. Or capacitance-wise. Tons! Dong. Where am I? So this needs to go down to ground. So we need another ground over here. Ground is there. Yeah. Let's grab another ground. Grab another wire to give us another ground. I'm gonna put these capacitors away before I flipping spill them. I keep nearly spilling them. Why can't I hold all these capacitors? Okay, can we slip this into there? Hold on. And that. And then... There we are. And just like that, we have another ground which we can plug in somewhere over here. I'm not sure where yet. Let's put it there for now. Okay, so we need a 22 ohm resistor as well. Did I get that already? I did, right? Oh, it's that one, yeah. Okay, so then it just needs to go through the 10 microfarad capacitor to ground. Which one's 10? This one's 47, so not that one. Yes, this one's 10. So with the stripes, with the stripe with stripes facing towards the dash, the negative side, let's attach that. I can go right in there. On the ground side. Actually, let's move it further down. Then we can put the ground there. Okay, so now I've got this area. Now we just need this capacitor here to come off the same side as this. It's gonna get a little cramped if I try to do this way, but I think it'll work. This is coming off the resistor as well. Okay, so now the speaker goes between the other pin of this 47 microfarad capacitor. The negative side it should be. Yeah, it is. Look, it is. Okay, nice. And ground. So yeah, let's just connect the speaker, I guess. I will these wires don't look very nice. Do I cut them and restrip them, or do I just solder on new wires because they're so goddamn tiny currently? I feel like I'm gonna get tetanus just by looking at them. That's actually maybe a slight exaggeration. Okay, let's just cut them for now and see if they go into the board. If they do, nice. If they don't, not nice. Okay, let's see. The first thing he said to me was, and I quote, "Don't touch anything you don't know the purpose of, and the multimeter is your best friend." The multimeter can be your enemy if you accidentally leave it in current mode. But yeah. Okay. So these wires might not even be wide enough. Long enough to get around this capacitor, I'm gonna be honest. Let's try. It's absolutely inevitable that I'm gonna accidentally snap the wires off the speaker. Like, these are the original wires, I think, from whatever the hell I pulled this out of when I was like a child. Put it there. Is it going in? It's not really going in. It's not really going in. How long until one of these wires stabs another hole in my glove? Is it in? It's not in. Man. Yes, I'm using wire cutters to try to push a wire in and not cut it. I may be a genius. Okay, I'm gonna say that's in. That's in enough. And the other side, should really get pliers. I mean, I have some, but not here right now. Right here, right now. This is stupid. I'm just gonna do this off the camera because this is silly trying to do with gloves. Hi Kim, welcome. New avatar? It's just because I'm doing 2D stuff right. Sorry, it's just because I'm doing electronic stuff right now. My webcam is like, you know, looking at the electronic stuff. Well, right now it's looking at my desk because I just pulled it away. But I only have one camera. Although there is my phone as well, but I can't mount my phone to something in an easy way to see this from this angle. Alright, that should do. Let's get it back on the screen. Join the stream. It's looking good. Breadboarding is the way to go. Thank you. Hi, welcome. Welcome. Mama Rolf? Is that how you should pronounce it? Probably not. Yeah. Gotta try it out this way. I mean, you know, I've already made the circuit on the simulator, but whatever. Software is one thing. does it actually work in real life? I'm not gonna like design a board without also testing it on the breadboard first. So yes, correct way to say my name. Oh hell yeah! Best fried. Oh my god, I thought that said best friend. I did not see best fried. Complimenting my comment, he had those because he worked at a repair shop in the 80s. Was called to service those giant CRTs. I always like to tell a story about how I had to crawl inside some. What the hell? I've never seen a CRT that big, one that can be crawled inside. That is actually really scary to imagine. You just lift your head up slightly too far and then zap. Why cheese, by the way, Azrael? Hi, Azrael. PNG tuber needs more cheese. She does not. She was coated earlier. I mean, well, it looked like she only had one slice because I didn't move it. But, so they all piled up in exactly the same position. If I keep my multimeter there, I'm gonna stab myself on those probes.
Cheese?
Which is not what I want to do. No cheese, no cheese. Okay, let's connect up the Arduino. There's a small chance that we'll actually hear something. It'll sound very weird if we do hear something. There's a very, very, very small chance we'll hear something because it might be the case that Talkie in the the library called Talkie, the one that's in that heavily modified state that I put it in to be able to time it and stuff, where it's just trying to render as quickly as possible rather than being at the correct sampler rate. It's slightly possible that it might still be setting the PWM timer to the correct value. In other words, it's actually outputting in like hardware D. Let's see if it is. Let's see if it is. You know, no, I'll plug it in first. It'll be a fun surprise if it is. But it's probably not. We should hear a pop as the speaker goes to like... Wait, will we hear a pop? If this is low by default, then... No, we won't hear a pop by default. The 5 volts... I think we'd just be putting this transistor turning on this transistor basically, which would short this capacitor. So we'd be actually holding the circuit low. Anyway, plugging it in now. Boop. Nah, it's not outputting anything. That would have been funny if it was though. So let's actually make it output something. Did I leave the bit that does all this setting up? Okay, maybe I should not be doing this in Notepad, but maybe I should not be doing this in Notepad. Let me hide the webcam for a bit because, well, you're not going to be seeing anything interesting there. Let's see. Did I remove all the setup stuff from this? So this is a library that I've modified to improve the speed of... Yeah, I have removed a bunch of stuff, haven't I? Man. Did I make a backup of the original before I removed it? Oh my god, did I seriously not? I didn't. I could recopy it from my laptop. Or I could just get it from GitHub, I guess. GitHub, where are we? The original Talkie, where is it? GitHub, Talkie. Not the refurbished one, the real original proper... Okay, proper is maybe slightly rude, but... Where's the original? The original version can be found here! I did say some cheese, so I give you some. I gave you some. It's very kind of you, but you don't need to. Random question, is the Uno card supposed to reflect the cheese? Is the Uno card... No, it's not. No, it's not. I find nitrile gloves to be the best option for me. Yeah, that'd be a lot better. These are the only ones I was able to get at the time. I just held them under the camera, but you can't see them anymore. Yeah, I don't have them. Will we see smoke? There was no smoke. Current is the only thing I suffer, resembling a phobia. What? I once chopped a wrench in half. crossing a couple of poles on a hum with 24 volt blah blah. Snakes? Wait. Height. Explode. Wait, hang on, where are we? Heights, explosives, loud noise, snakes. Wait. Problem. Why was there a sensor not coming in? But electricity is a bit dodgy. Also high battle gnome. Alright, where are we? Where's the thingy? Talkie. Here we are. Let me just grab this file actually. I'm not sure what's gonna appear when I click this button, so I will save that into here. Okay, we're safe. We're safe. It's been saved, and I'll grab the original H file as well, which I don't think I need. I don't think I deleted anything from the original H file. We'll save that into there as well. Okay, this is where using an ID will probably be making this much more enjoyable. Will this be enjoyable, or will it just be annoying because it's complaining about not knowing where all the libraries are? It'd probably be annoying because it'll be complaining about not knowing where all the libraries are, so let's not do that. I'll just do it using Notepad. Why not? Because it's ridiculous. But also, why not? Nyan. Yes, it's a mirrored and an aceton together. Okay, where's the stuff that says on the timer? Here it is. If not set up. It's weird that they just chose to put this inside the save thing rather than breaking it out into a, you know, separate thing. Yeah, I'll just make it do this every time. I don't even need to see if it's set up or not. Just do this. Just in case. It's done once at the very beginning of speech, so it's not a big deal. Let's put this right at the top. I'm gonna call this void setup. Might be a bit of a confusing thing to call it. Let's call it talkie : init. Init bruv. And this is where I'd want to unindent this somewhat, but... Oh, wait, I can. Thank you for the hydration, aceton. I'm actually willing to edit the H file, because I'm adding init. Init dobrav. I have these cutters out now, so I can cut off the bits of the Nyan juice bottle that like to hurt me. I can actually show them on the webcam now. Look at this. Look at this. This is the cap of the bottle. Look at that sharp thing coming off the edge. And also over here there's some more. But wait, there's more. Wait, where is it? Wait, is there not more? I don't think there is more in this one actually. No, there's not more in this one. Anyway, I'm snipping it off. It's off. Okay, on Notepad /gedit is hardcore. It's like flying blind. Is it? I feel like it's roughly how it is with the Arduino IDE. At least the 1 point something that I'm using. There's no auto-completing stuff there. It does sometimes make a word turn red if it's a recognized function. Sometimes. But apart from that. Okay, so we want to do this when we start speaking. So this is going to be in say. We will do say. Very obscure reference. If anyone knows what that's from, I'll be impressed. So we're going to do init. And then all this is indented further than I need it to be, but it's a pain to unindent on Notepad, so I won't. So let's define init in the H file as well. I hope I'm editing the correct one. Was I editing the correct one? I was. Okay, H file. Private. Private. Void. Init. What have I been missing? What have I been missing? I've been missing something. It's just you can't see it. You go to pick up a saw on a construction site or replace a battery, you don't realize it's not grounded. And whammo, you are the ground. If you're touching something else, yeah. Mind you, if you're like working on a high voltage, you'd rather not be grounded, right? Otherwise, otherwise it's gonna go through you. I guess there's a time and a place for it. Not to add to your phobia, but a childhood friend went fishing. His fishing rod hit an electric pool? Wasn't an electric pool? What the hell? Why is one of the pools electric? Man. Yanju's reveal. Just the cap. Just the tip. Okay, so I want to make sure that inside... Oh, this is the non-modified version. I want to make sure in this one we are sending it out still. That'll be in make sample. No, okay, so instead of next PWM, I don't know why they did it this way. I might find out why they did it this way in a moment, like unintentionally. We don't need this. We can just output it directly. This I may find out why they did it this way in a moment. But we can just output this value directly. Instead of doing this, we just set the... what is it? Output compare register... to... Shit, I forget what it was. Hold on. Which one was it? What's the name of it? I don't remember it. OCR, where are you? Not that one. This one. OCR 2B. Okay. OCR 2B. I was one letter off. I almost remembered it. So this is the register that says what the timer should be counting up to. And this is the timer that is driving the PWM as well. Well, this I think this is the value that it counts up to before turning off. And then when it restarts, or when it overflows to 0, it turns on the pin, I think. And when it goes past this value, it turns off the pin. So that's why if you write a value of like 10, well, you know, when you do analog write, it's basically just setting this timer to 10 so that the timer will turn the pin on when it overflows to 0 and then off when it reaches 10, and it'll keep on counting up to 255 until it turns the pin back on. So you can see the pin will only be on for a tiny amount of time. There's an entire ass Discord of Leapfrog tech people run by the guys who built the LF manager, which I guess is Leapfrog manager? Currently, with current, you can possibly do a current way of handling the current phobia. Sheesh. Alright, so we should be outputting now. So we should be setting up the timer and we should be outputting. The only problem is we're calling this as quickly as possible. So we want to make it so that we are calling it less quickly. So timer 2 is the 62.5 kilohertz and timer 1 is the 8 kilohertz. So we want to, so there'll be like an interrupt thingy originally. This is not the original, is it? This is the original. Okay, so yeah, we're just gonna do this on the ISR. When the 8 kilohertz timer ticks, instead of as quickly as possible. So instead of being make sample, this thing that we have to call manually, we just make it the timer interrupt service routine. And then instead of calling this as quickly as possible, we do what the original did, which was just wait for 25 milliseconds, which is blocking. We don't need to do that eventually, but I'm putting it back to how it was originally. So we delay 25. That should be it. That should be it. Talkie should now be basically back to how it was originally, but more efficient. And also with interpolation now. Maybe if the circuit works, we'll even hear it. Shall we see? Gotta upload it first though. Also, oh, let me stop the thingy where it's outputting timing information as well. Why are we doing that? Where's the original? Is this the original? I think that was an old version of the original. Port B, there we are. So this is for timing test. I'm typing with these gloves on, by the way. So we don't need to do that anymore. In fact, we really want to not do that because that's going to force off the pin and the thingy is turning on. Timing test, turn off, pin 12. Are we doing anything else with port B? Anyway, port B. Nope, just those. And now they're commented out. So we don't need to do anything with that anymore. We definitely don't want to turn off interrupts. And then we're just going to try to read this. You know what? I'm going to put this inside loop, in fact. So that it keeps on playing over and over. And this is the Uno. It's on no port because I haven't plugged it in. Whoops, let's plug it in. Now plugged in. There it is, COM11. And upload! Compile first, I guess. Yeah. Put these bags of transistors. Actually, maybe I shouldn't. Error? What the? Huh? Wait, what's wrong? Okay, where's the actual error? There's a lot of warnings. I know why the warnings are, but I didn't expect it to be an error. Next PWM was not declared in this scope. Ah. I might be about to discover why they did it that way. Next PWM inside... Where is that? Oh, let's search for it. Next PWM. Oh! Wait, they're just setting it here. I'm gonna not do that, in fact. We'll set it here. I really don't understand why they calculate the value and then they wait for the next frame before outputting the value. Why not just calculate it and then output the value? I don't know. Let's try it again. Boop! We had a radio operator on a trip. Hang on, actually, we'll be able to hear this as soon as it uploads. So let me just turn this off, just in case it works. It's uploading. Okay. This is not quite correct. It's nearly correct. So the decoding is actually working, I think? I'm not sure if the problem is with the circuit or something to do with something else. It sounds pretty cool though. This is so fucking loud. Jesus. I'm gonna unplug this for a moment. Whew. That's loud. I took off like one ear of my headphone and I realized that it's actually a lot louder than it sounds through my mic. I'm glad I'm not doing this at like 10 PM. Or gone that. The question is, do I build an entire VM to hold all of the Leapfrog software? Man, we're getting some sound! How cool is that? I actually want to feel how hot these things are though. Which means turning that off for a sec. Let me see if anything's getting warm. Anything getting toasty. How are we going if I plug it back in? Brace yourself. Just feeling things. Okay, hold on. Hold on. I can't tell. Let me touch this to my lip. Oh! Okay, one of these transistors is kind of warm. That's, possibly not meant to be that warm. Also, this is like way louder than I need. So what I'm gonna do is change that 22 ohm resistor so we're not trying to short as much current when the thingy turns off here. Like maybe increase this a bit so this graph will look weaker. So we're going to be charging the transistor, what am I talking about? Charging the capacitor more weakly and discharging the capacitor more weakly. Oh, wait a minute. Why didn't I just hang on? This is a perfect opportunity to be probing it as well. You know what? It's probing time. I'm turning on this. I'm not because there's not power to it. Hold on, I have to connect power. One sec, I have to plug in the oscilloscope. Ah. Okay. Yeah, let's see what we are even giving it. Let's see what we're even giving it. Let's see what we're working with. What is actually happening? Thank you very much for the follow, Super Bambi. At least I know that I'm not actually gonna break something because the transistor wasn't scarily hot. It was warm though, and like if the circuit diagram is correct, we shouldn't be pulling more than 40 milliamps. No, 100 and something milliamps. Am I discharging right? Okay, that is actually quite a bit. All right, I think it's time to get probing. Temptation to say probema is rising. Alright, where's this? Here it is. Probema. Thanks, Yif. Hi, Yif. Welcome, welcome. It's such a fun design system thing to stare at. It really is. It really is. Here's the full thing. Let's slow it down a bit more. Or speed it up more. No, I'm not sure what's best. Give me 10! Oh! Oh, I thought you were just saying probema because I was holding back from saying it. Alright. How do we measure this well? Would be useful to be able to use the ground clip rather than the springy thing. So let me remove that, and this will be in view on the webcam shortly. Please hold. Preparing. This is the please hold preparing music that's beginning now. Ooh, it's infected mushroom. I just pressed the next track. I wasn't sure what I was gonna play. So ground is actually where can I easily? Yeah, where's ground? Where's ground? I think this is one of these is ground. Continuity test, my beloved. Oh god! I just knocked the Nyan juice bottle over. It's okay, it's closed, but like, that's gonna make it release all of the precious fizz. Sad. Near smoking grate? No, it's nowhere near smoking. It's nowhere near smoking. It was warm, and that took me by surprise because I wasn't expecting it to be warm. Okay, which of these is ground? This one? Yes. This one? How can it both be ground? I guess it makes sense. Okay. Let's clip this on there then. Hope it doesn't damage the board. I always get a bit scared when using the crocodile clip thingies. They seem so violent. Bum, 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 bum. And that should work. Okay, I think that should work. And then any more that I need to clip on stuff. Okay, let's start by getting the damn thing on the screen, shall we? I just grabbed a bunch of parts and stuck them into the breadboard. You made one of your electronics kids as a kid smoke. Oh my god. Oh no. You just randomly plugged stuff in? What a rebel. What a rebel. I don't know why I'm saying that. But I'm saying it. Hold on. Untangling things. Probe. Please don't be tangled. In before Yif says Tanglema. Maybe one of the transistors is broken? I'd hope not. But, we'll see. We'll see. Alright, let's get this up on the screen. Ah, right. I'm gonna have to change how things are cropped now, huh? Guess I can just pull this down there? Sure. It's gonna be a bit of a weirdly scuffed looking thing, but anyway. We also don't need statistics on, we don't need any kind of measurement on right now. And let's trigger on channel. Oh, we don't even have the correct channel turned on, what the hell? Get off. We're gonna trigger on channel 1, although I'm not even gonna be triggering it first, I'm just gonna have it on like a rolling view. We'll watch stuff as it happens. Angle sorry, I was distracted, no worries. Okay, let's see what's being output first. Let's probe what's going into the resistors from the Arduino when I plug this in. It's still gonna be annoying actually to keep on plugging and unplugging it from the. Let me do it from my computer instead. I have to be a little bit careful, or I might just accidentally press the power button on my computer there. Or the reset button actually. Why? Okay, can I just jam this in somewhere so I don't need to be holding it the whole time? That'll do. Very nicely. And let's plug it in, see what's happening. There it is. Okay. Okay, hold on, let me change. Wait, why are we not seeing it? What is the trigger set to? Oh, that's why. Oh, wow, that looks really cool! Okay, let's... Wow, it's kind of fun. I unplugged it while it was still going and you can see the voltage dropping. Let's maybe not do that. Let's just press stop on the scope before I unplug it. Okay, that's too little. Come on, Nuke. Come on, Nuke. You can do it. That'll do. No, it won't. Hold on. Wait. There, that'll do. Thank you for the hydration and the PATS spray and the posture check Vance. We'll zoom into that capture in a sec. This is the PWM signal coming right from the Arduino. It looks like it is nicely changing, which is good. Does she sound like she's in pain? I don't know. I hope not. Hey! She's not in pain, I swear! Okay, let's take a closer look. Actually, this is... slightly is that suspicious? It is a little bit suspicious. This does not look like it's going between many different values, does it? Or is it? See, this looks like 50% right there. That looks like about 25%. 25%, 50%. Maybe a quarter. thing is, I've already run the same decoding code on my computer, so I know that the actual values are not clipping. Oh, wait. Hold on. Maybe there is weird things happening, weird stuff happening because the original value is signed. Where's the library gone? Hold on. The original value here is, oh my god, where is it? Signed. And so this value here is signed. When we add this is gonna, well, I guess it would just work, wouldn't it? If they both overflow. If they both overflow. Let me change it into a way that I know will definitely not, we won't have to worry about all this. If we change it to allowing only much smaller values through, and then where is that OCR2 be above? This value here is the one that we generated on the previous frame. This used to be a static variable. I don't know why they're doing it that way. Because I know for a fact that this value down here is the value we want. We could just change it to work that other way though. Let's change it to work that other way. I'm also putting this back. So this will sound quieter, by the way. Possibly. Yeah, I'm changing two things here. I'll change it back to this. Maybe, I wonder. We'll see if that was the reason why. I mean, it doesn't explain to me at all why it would be sounding distorted, but okay, let's upload. This will sound different because I'm clipping at a different value. But, unless it sounds super clean... Hang on. Uploading. Okay, it's more just noise now. It kind of sounds like we're hearing like the lowest bits. Like a lot of noise, you know? Thank you very much for the follow, Soundboy. This is possibly not the best sound that you're hearing right now. Okay, so that wasn't the problem. I'm quite confident that's not the problem. It does rather sound like we're only hearing like some very low bits. But I think the value is arriving not terribly, is it? We're seeing something that's like low. Oh, you know what? Shall we just let's just try to generate a sine wave. Or a square wave to begin with. And we'll just gradually... no, let's just do a sine wave. We're not even gonna use Talkie. Let's start a brand new thing. Well, I actually am gonna use some code of Talkie, the one that makes the PWM run at 62,500 hertz. And do this. Okay. So we're gonna do that. And save this as, let's call it push pull test, I guess. And then let's just make a sine wave-ish thing by, well, I guess a triangle wave, by making a value gradually go up and then down and then up and then down and up and then down. But we don't do it too gradually. Otherwise the pitch will be too low for us to hear. Because this circuit is like actually high pass filtering it. I mean, it's not like a brick wall filter, so some stuff will still be audible. It's beautiful. Aww, thank you. It's not meant to sound like that though. That's a really cute emote. Thank you though. Okay. So Let's do a little loop. Let's make a variable that is boolean, which is up now. So if this is true, we're counting upwards. If it's false, we're going down. So we go by default. Let's call this the PWM value. Sure, we'll start it at 0, and we'll just go into a loop forever, and we'll say, firstly we'll count up. Well, if up now, we'll just go into a for. Well, we'll just do a while actually. While PWM val is less than 255, we'll do a thing. Else, and afterwards we'll toggle this up now equals false, and then while PWM val is larger than 0, which is also just the same as saying while PWM val, but for ease of reading I'll keep it like that. Then we just want to set the PWM value, which is they're doing here by setting OCR2B actually. I guess I could just read that directly, huh? I wonder if it's safe to just read that directly. It's probably safe to just read that directly, right? So we don't need this, we'll just do this instead. So we'll add 1, and we'll subtract 1. I'm hoping this is unsigned. What do I want to do next? We want to have a small delay. I don't know how reliable this is going to be. The timer for delay should still be working fine, because this time is 0, I think. So, let me think. If we're counting 255 steps up and 255 steps down, that's 512 steps. So we actually want to sleep for only a very tiny amount of time if we want that to be like 1... If we want it to be like 1 kilohertz, then we want to do one of those like every 2 microseconds, right? Because we want the entire loop to loop every 1 millisecond if we want it to sound like 1 kilohertz. So we can't even delay by a short enough time, actually. The shortest we can delay by is 4 microseconds, I think. So let's just do that. This is probably going to be less than 1 kilohertz because we're going to have all the overhead of this crap. But I mean, it's obviously going to be less because 2 is the ideal. Maybe we don't need a delay. Maybe the slowness of the Arduino is like enough already to... Whatever. Let's just upload this and see what happens. Let's. We should at least hear something, right? Surely. Wait. Has it already been like turned on at this point? I guess it has. We are uploading. We should hear a tone once this is uploaded, hopefully. Oh shit, there it is! Wait, that's a pretty clean tone. Hold on, let me turn off my noise again. Listen to that! That sounds pretty nice! So wait, the problem is in the decoding of the voice? Oh shit. That's not good. That's kind of worrying. Also, while this is running, let me just turn that off and feel the transistors. They are the tiniest bit lukewarm, which is honestly probably just my bedroom temperature. So I guess they were being driven into like a square wave or something. Anyway, let's see what it looks like on the scope. Here's what's being sent out. Let's zoom out a bunch. Nice, you can actually see the repetition there, but let's just hold that and zoom in. Oh, beautiful! Look at that! There's low, and then it gradually becomes 50-50, and then mostly high, and then inches high. And then it goes the other way. Nice. Okay. There are no up? There are, but I'd have to use inline assembly. Okay, that's really nice. That is remarkably stable sounding as well, despite, you know, there being interrupts running. This is... hang on, let me just get this closer. There you go. That's actually what it sounds like. There's like, you can hear background noise, but that noise is not coming from the speaker. Wait, can you see the... you can see the... oh no, you can't actually. There, you can just see the very edge of my mic. Okay, that's good. I'm plugging this in. Actually, I'm not. I'm gonna probe and see the other things. I want to see stuff working. Let's look at our circuit. Because at least the circuit seems to be working. Thank you for the pass, Hickey Dev. I was not expecting the circuit to work and the other thing to not work. That's like the opposite of what I was expecting. Okay, let's run the scope. Continuously. Let's measure the... well, there's not really anywhere else I can measure. I guess I can measure the input to the... I can measure, hang on, where's this flipping diagram? I can measure blah 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 blah. Here. So this is like the input to the, what I guess you would call a bandpass filter, because there's a low pass and a high pass. So if I can just measure between those two resistors? Oh, transistors, there we are. That times the channel. Okay, this is what we're measuring. And we zoom in. Oh my god, look at that. Just freeze it. Wow, look at that. So, like, it is starting to discharge sometimes. Oh no, this should always be doing that. Never mind. Yeah, because this is before the filters. Okay. So let's see what it looks like after the filters. What is the speaker actually getting? How much of the 62 kilohertz is remaining? And where do I probe? There? Yeah, that looks right. There. Oh look! It's actually AC! Nice! It's actually going below 0 line. That's very nice. Zoom in a bit. This is kind of lower voltage than I expected. Can we just run? Oh wow. Okay, this is not filtering very well at all. Like, that's not filtering at all, the really high frequency. It's still right there. That's not good. That's not good at all. What the hell? I mean, it is filtering a bit. Wow, it's still there. I was not expecting that. Might try some different components, I guess. Interesting, interesting. Alright, so the good thing is the circuit is working. At least, no, it is working. We're doing the full range here, 0 to 255 and back again. So yeah, that's working. So the really weird thing is that the decoding is currently not quite working correctly. Why on earth is that? Why is that? Why is that? Of all things, I was not expecting that to be the problem. Because I've already tested that on the Windows thing. I wonder if I'm accidentally using the wrong data type somewhere. I think I might need to... Also, hi, Dr. Dankenstein. Triangles are my second favorite wave? Hell yeah. That was most definitely a triangle. A trongle. Did I say hi, Hickey Dev? Hi, Hickey Dev. And thank you for the pants. I may have said both of those things already. Where are we? I did call init, right? I didn't forget to call init, did I? Did I actually call init? Did I initialize? I did. Okay, good. Good. So So I think the speech is decoding correctly. You can hear the pitch and everything like basically correct. It's just for some reason coming out really distortedly. So that must be like a pretty late stage thing that's failing. Well, something in here that's failing basically, not the say thing. Man, this kind of sucks because this invalidates all of my timing, the benchmarking I did of this. It's like, yeah, wow, it works really well now, but it doesn't actually make the right sound, so what's the point? Hi Aximony, thank you for the luck. Lurk. I'm getting hungry. At least we made a circuit that works. This is a really short stream. But I'm not gonna end quite yet. Not quite yet. Soon. Not yet. We don't need this. So yeah, setting this value is also fine, I think. I mean, this interrupt here, which is running at 8 kilohertz, this entire thing that we're looking at, is like asynchronous, if you like, compared to the 62.5 kilohertz. So like, it's not really gonna make a difference whether we set it a little bit above or a little bit below, right? U0 is being clamped there. Alright, I'm gonna compare it to the Visual Studio project where we know that this works because we've literally listened to the decoded audio. So, well, let's do some side-by-side comparisons and work out what the hell we're doing wrong. First Beaker Boy synthesizer. Oh wow, that sounds pretty fun. Congratulations. Congratulations. Okay, so it's basically the same code. Just with a tiny difference somewhere. Like, we're no longer writing to a file. We're, like, outputting. But look, it's the same value that we're outputting. Ah! But... no, it's unsigned, right? It's unsigned. The value is, it's unsigned. Right? Right? Open raw data. Unsigned 8-bit. Yeah, this is what it should sound like, by the way. But it's not quite sounding like that. I mean, you can make it out. Like the pitch and stuff are correct, but for some reason it's like incredibly distorted. Okay, so this code works. Let's double check that this code actually works. Let's run it again. Just in case I made some changes before copying it over to the Arduino. Oh, can you imagine? And then this one no longer works? Okay, so it's just run and it's decoded it and it's written that file. It's imported again. Really make sure this version of the code works. Here's the file. It was last modified, like now. So unsigned, one channel. I'm not even going to bother to set the sample rate. Yes, it's correct. It's not horribly distorted. It's going to play very fast now because I haven't set the sample rate, but it's kind of funny. Sorry, any cats and dogs. Kind of glad it didn't go modular. Ah, okay, so it's not modular. I see. I would ask what it is, but I probably wouldn't know. Because, stuff. Long Uke became a mouse? Maybe that's what the small ones sound like. God, the Arduino doesn't stand a chance of being able to decode fast enough to make such high-pitched noises. Premise Superior, where are we? Say, okay, no, this part must be fine. I think. Possibly. Maybe spitting some stuff out to the serial port might help. Doing that inside an interrupt service routine is possibly not advisable. Possibly. Something tells me we're not going to be able to send 8,000 integers per second on the serial port. Okay, let's see. What are these? I feel like this must just be a type problem, like I've set, or I'm casting something to the wrong type somewhere. Like something that should be 16-bit and it's 8-bit or something like that, you know? Like we're only hearing like the lowest some number of bits is what it sounds like to me. Period counter and PWM, which we don't need. Why am I still leaving that defined there? Anyway, these are all in 16Ts. They are here as well. How are these ones at the top declared? We have target synth period, uint, and then int, uint. This should be 8, but I also don't think that's the problem. But let's try it anyway. Maybe it is. Okay, I wasn't expecting to have accidentally left something wider than intended. Okay, that was a difference, so let's recompile and see if that was it. Otherwise, I'll just keep looking for differences. Should probably keep looking for differences anyway, but... let's recompile. Turn off the noise gate so you can hear it. Uploading? Nah. Okay, not yet, not yet, not yet. Not yet, still clipping. Wait, I just turned off more gate. Arturia. Ooh, I remember looking at the microbrute. Arturia Mini Freak. I think they're recommended for beginners. Interesting. Mini Freak. Why does that sound vaguely familiar? I'm gonna look that up. Hold on. Let me have a look. Arturia Mini Freak. Not sure why that looks familiar to me. Let's take a close look. Where is the actual image? Where's the image? Here it is. Yoink. Is this like a matrix where you can mix the... like you can root one thing to control another thing? Like LFO1 can control the pitch? That kind of thing? And the wheel could... oh, this is really nice. This is really satisfying, actually, to see a matrix like that. That's very cool. Oh, and you can, like, set an amount, so it doesn't have to be, like... oh, yeah, obviously. Otherwise, LFOs, like, all or nothing would be ridiculous. That's really cool. Are these, like, knobs? This is kind of... this looks fun. What the hell? I don't know why, but I just really love icons for things. Just being able to see all these looks really cool. I guess it's like the step sequencer kind of thing? Maybe? Arpeggiator? Mutate is a radioactive warning symbol. Nice. Alright, that looks pretty cool. That looks like it'd be fun to play around with. That looks like it'd be fun. Arturia is amazing for UX. Looks like it. Rotary encoders with press and touch sensitivity. Touch sensitivity? Okay, interesting. So you can like, you mean like you can just sort of go like, before you want to dedicate, like commit to something, you can just like tap it and like the LED would like light up or something, but not apply, and then you just go like fully and then it applies to something? Oh, touch to show value. Oh, okay. That sounds much more useful than what I was suggesting. Okay, there, uint 8, target period and target energy, since current. These are int 8s, okie extra pitch accuracy, I've also got defined there, which is interesting. I don't think that's the problem. All these are ints, energy and period are uint 8s, uint 8, and then these are just int 8s. This is almost copy and pasted though. Num interp shifts. 8 3 3 2 2 2 1. Volatile. I wonder if there's something that's not declared volatile. It should be, but probably not, right? Because it's not sounding weird in that way to me. It's not like there's sudden corruption happening. Hi, Trades. Why cheese? Why cheese today? Hi, Cat. Hi. Don't need this view on right now. You can also press and select if you're dexterous enough. Press and select. Press and turn. Oh, okay, yeah. End sum total is not necessary. Man, what have I missed? What have I missed? This is so weird if everything is the same and it's not working on there. Then the difference is like almost due to the compiler, you know? Because this is 32-bit and the, well, like the default, wait, no, that's not right. That's not how C works. It shouldn't be dependent on the compiler like that, right? Like, I define explicitly the width of all of these, so like it should work the same whether it's on an 8-bit CPU or 32-bit CPU. Like, it will just be more clock cycles to do a 32-bit thing if I define something as 32-bit on there. Like, I'm thinking like the... Hi Nora, welcome. I'm thinking like the intermediate values and stuff are still gonna be like computed in the same... with the same width, right? No matter what CPU it's executing on. Because these are int 16_t. It's not like int, you know, where int on here is 32-bit, whereas on here it'd be 16-bit. I don't think there's ever anything unexplicit like that. Reverse path. These are all in 16Ts. X0 is U0. There is actually still difference going on here. Like on here, the entire thing is within an if current synth energy, but this should, this would only explain it continuing to make sound when it shouldn't. Let's put this around everything here as well. Everything else should just be this. Close that, else, on voice, static, that, U10, blah blah. This is where there's a debug thingy, but there isn't here. Let's just put a new line to make it easier to read. Oh god, I'm failing to press keys sometimes with these gloves on. Oh my goodness! What is happening? Help! Okay. Oh my god, this is really annoying. These gloves are an overall very annoying experience. Would not recommend. Should look for nitrile ones. Okay, so then otherwise, if the synth energy is not greater than 0, the output waveform position should be 0 signed. So we offset that. But that should not explain why stuff. Enstamp of frame is completely irrelevant now because it's being done. We shouldn't need this at all anymore. This is being done. Enstamp of frame. Where is this being done? Oh, we are passing it in this one, weren't we? We're passing this in. Yeah. In any case, we're not using this anymore. Hopefully. Oh, never mind, we are! Oh! Oh! Are we ever resetting this? Ah, okay. I see the problem. I see the problem. We're not resetting the... Well, I see a problem. I don't know if this is the problem. Where is that being reset? So that needs to be being reset to 0 at the start of... At the start of the next thing. Just before the delay. Where the fuck's the delay? There it is. This is where we should be resetting this. Okay, let's try that. Basically... Would we have been, like, Would we be like interpolating over and over and over? No, that wouldn't have made sense either, would it? Is that why? That is certainly a mistake. Let's see if it works now. That was definitely a mistake. Are we still incrementing it in the timer? We are. Okay, let's see. Let's see if that works. Let's see if that works. Boop. I would expect it. Yeah, I would expect it as well. High trades. Okay, this might fix it. Fuck! It didn't fix it! Damn it. Did I forget to save? Shit, I didn't forget to save. Nope, I didn't. I was really hoping it would say, do you want to save changes when I did that, but it didn't. God damn it. Okay. We are resetting this to 0 as well, right? Yes, we are. I feel like there's some very silly problem somewhere that's just because I've changed to like this, doing it through the timer, and there's some bit of code that I've either accidentally removed that I shouldn't have removed when switching from the file writing code here back to the timer code here. Or something that I haven't added that I should have added for the timer related thing. Am I clipping or what's going on? Yeah, the values I'm outputting are wrong. I've just output like a triangle wave in another project, and that's fine. So it's not a circuit problem, I think. Although the triangle wave did have a lot of overtones, not overtones. The 62.5 kilohertz PWM thingy was still louder than I expected on the output. Obviously I didn't hear it, but when I probed it, it was like quite prominent. So maybe I should make that low pass filter a bit stronger. But that's really just tweaking. I'd rather get her voice sounding a bit better first before I worry about that. PWM for audio is kind of dodgy to begin with. I would say not really, because I've already made the project like that confirms that that's not the problem. Fun fact: that's how the Raspberry Pi does its audio. If you measure the audio output of the Raspberry Pi 3 at least B, you'll get like, I can't remember the exact frequency, something in the hundreds of kilohertz. And then if you connect that to an amplifier, the amplifier will be very unhappy unless you low pass filter it. Hi Hollow Tempest. Welcome. Alright, where are we? Where are we, man? What am I doing? What am I even doing? RPI audio is also dodgy, emanating a sine wave with a square wave. It's not that unusual. Like, at some point, if you're doing digital stuff, it's like, unless you're using a resistor ladder kind of DAC, then it's probably going to be done through PWM at some point. It's just cleaned up with a low pass filter. Right? Right? I haven't changed any of this stuff. Have I? Break, blah, 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 blah. In-type shift is in-type shifts. So this is a thing that we're not remembering that between thingies. No such thing as a pure digital sine wave. Yeah, in-type spread stage. This is marked volatile? This is reset to 0 initially, right? This isn't some uninitialized memory crap, is it? Is it? Nope, that does get reset to 0. Interrupt spread stage also gets reset to 0. And this also gets reset to 0 eventually. Hmm. Man. What am I missing? What am I missing? I can't believe the decoding part is going correctly, like all of this stuff. Like you can make out the stuff, it's just horribly... Alright, fuck it. We are going to attempt to do some serial debug printing, and this is going to probably make things implode because we're going to be trying to do a very slow thing inside a timer callback. But hopefully we can get some meaningful values before it crashes. I just want to see what the hell's going on. I need to take a view of the insides, even if I'm gonna upset it. Where is serial.begin 520. Wait, capital S, isn't it, for some reason? Okay. Yeah, sure. Inside here, I'll do... well, as a sanity check to make sure it's not a problem with the circuit, we can be outputting the value here. So we can just say serial dot print this, and then also serial dot print space. Wait. Yeah, sure. This should be no, hex actually. Then I can copy and paste it into a hex editor and listen to it and see if it also sounds just as messed up. We're likely going to miss a lot of things, so... Yeah, we're gonna hear like skipping audio if I do this because these timers are gonna be running... Okay, the problem is that the delay... There's a delay of 25 milliseconds here, but not much is going to get done in 25 milliseconds if we're printing out to the serial thingy. So what we should probably do instead is wait for it to actually have output a certain number of samples, which is while in samp of frame is less than 200. Well, I can just redefine this actually. So we're actually going to overshoot slightly because we're only going to stop as soon as we reach it, and then we're not going to have set up for the next frame yet, so we're going to like overshoot slightly, but whatever. Anyway, so we're going to keep outputting once we've already reached it. Anyway, let's see what we get. Let's see what we get. We should get crab load of hex values being spammed is what we should get, but... Boop. Is it uploading? This is going to sound very weird not running at full speed. Oh, I actually can't hear it. It's unhappy. Okay, so he should have just got a load of these. Okay, this looks extremely suspicious for a start. There's so many FFs. What the fuck? Okay. Very sad along here. Yeah, she's a little sad there. Pacing is not possible. Wait, why? This should literally just be hex values. What the? Oh, that's weird. Okay. This should just be hex values? What do you mean? What do you mean? What are non-hex values? Huh? What is this? Are there non-hex values in here? Oh shit! There are. Okay, yeah, this serial data is not coming through in a non-corrupted way, which is sad. Okay, whatever, we're seeing crazy values. Mind you, this is... No, this is meant to be unsigned at this point, right? Okay, do we have good hex values now? We do! Okay, let's save this. As, I don't want to call it a sad long nuke. Noise, noise dot raw. What does it sound like? 0x80 is 0 and int 8t. Anyway, let me see what this sounds like. The fact that it thinks it's signed 16-bit because of how weird the data looks is not a great start. Anyway, this is probably going to be sounding fucking horrible. Yeah, so this is pretty much what it was being output. Let's see if it sounds similar to what was being output. I'm turning the volume down for you. You can thank me later. Interesting. Okay. We're seeing crazy values is the thing. Sounds fun though. Sounds about right. 0x80 should be 128. 0x80 is 128, yes. Why did I close then? So 80 is good. Why are we suddenly going to FF sometimes? This is very much not right. Jim had to get a calculator? Oh, don't worry. I know that feeling. So yeah, basically the value should be 0 most of the time. The value here is signed. Or it should be signed. Yeah. And then, huh. What if I just change that to 128? Instead of doing it in hex? Because, like, this is meant to be, like, you know, a mathematical thing. But it makes more sense to me like that. I'm sorry, Long Nuke in advance. I can see it just spamming the serial port output. Okay, this is running much more slowly now. Not quite sure why. Not quite sure why is it making it run more slowly? This should be incrementing by 1 each time. Where are we changing it? 1 there, and setting it to 0 there. And as soon as we're done... Oh, because I've still kept the delay there! Oh my god. I kept this, and then I added a delay as well. This is meant to be one or the other. Okay. That's why. But unfortunately, that didn't fix the distortion. So... I think she's in agonizing pain. She's not, I swear. Her voice is just a little broken right now. She has a bad throat. Yeah, I'm very confused by this. If this is a larger 127, we clip it to 127. If it's less than that, we clip it to -128. There were different values before, but it didn't really matter. It was still doing it. It just sounded even noisier before because we were like hearing only the... Nyan. How about I print out the U0 values? How about I print out the U0 values? But then I have to compare those U0 values to the... to the values that are... Also, slight sanity check. It's not because I'm like putting volatile first or something, is it? It's not like that stupid, is it? It's surely not. Surely not, right? Surely not. Right. It does still compile. I don't know if the size is different. I wasn't taking a close look at that. How many bits? 8-bit.
Beep boop bop bingly bongly bang.
She certainly is beep booping. Hi, Liquid Cake. Welcome, welcome. Okay, it's still doing that. Still sounding like that. Why is that? Why is that? Calling the police? Long abuse? No! Absolutely not! Absolutely not. U0 int 16T? Yes. This is like, that's like part of the original code though. I haven't changed that part. I thought. Are you getting the hardware to talk? Hey, you know what? That's actually a good point. Shall I am, yeah. Shall I try the absolute original talkie library at this point? I think I should just try the absolute original talkie library at this point. Like, you know. The really original. Ukified. I feel like I should just try the absolute original. What am I doing?
Buy it, use it, break it, fix it, trash it, change it, mail, upgrade it.
Wow, she said that pretty well. What the hell? Hi, Tellerian. Welcome, welcome. Okay, so we should just be able to call this in the exact same way. And this should decode, by the way. That won't be interpolated, and it'll be quite quiet. But this should just play like normal if this works. It's uploading. It hasn't uploaded yet. Wait, what? Wait, this is the... Wait, this is the original now. The original is still sounding like that. What the hell? Wait, hang on. Sanity test. This is the original, right? Yeah, everything's hex now. This is the original. And this should be no... Yeah, this is much shorter. This is the original. And the original is sounding like that as well. What the hell? Some of the sounds that greet me will probably find themselves in my dreams. Nightmares? No! Hopefully not. Well, I mean, that's the original. That's actually the original. We could even just run one of the... Actually, one of the examples, you know? With some other voice. Where is it? Talkie. UK Acorn. Sure, it's literally the only thing that says UK, that's the only reason I chose it. This is the Acorn computer file from 19A-T3 pause. And it's gonna say it once apparently, so rather than loop it. Alright, let's upload that. I'm waiting for it to compile. Oh my god, it can't even fucking... Maybe the, maybe this is actually, you know, something has actually changed. Because this used to compile. This is an example that no longer compiles. So, maybe something has actually changed. And this is why it's no longer working. But it's weird because the code works on Windows! Anyway, upload. Hi, Crostan. Welcome, welcome. Okay, it's uploading. Hang on. There is something playing. It's extremely quiet. Where is my volume silence? It did just play really quietly. Let's get the mic down there. And press reset. I mean, that works. That works fine. Okay, I mean, that worked. So what if I just take the long uke thingy and put it in here? Did it just not wait. This isn't a case of it just not recompiling the library, is it? Because I haven't reloaded the Arduino IDE at all yet. Let's see. Let's just put that there instead. This, the one that used to be called pause 1 is now this. Upload. I'm putting the mic up to it, so I'm sorry if this is really loud. There it is, it's correct. That is so quiet. I mean, there it is. There it is. And yet, for some reason, this code, when this was uploaded... Well, the only change... Yeah, okay, we don't need that. The only change is... This is included. Talkie voice. uint8t const. uint8t const. Blah, blah, blah. Progmem equals blah, blah, blah. Voice.say. There's no difference. There's no difference except for what I called the variable. Is this literally just that it didn't recompile when I fixed something earlier? Is that what it was? Who knows? Let's try re-uploading this, I guess. We're gonna close the vocab UK acorn. Get out of here. We're now uploading this. Which should basically do the same, just in a loop. And there's a, like a blocking thingy there, so that won't return until it's done. Why is it so much louder? I'm really, really suspicious. I'm so suspicious right now. Literally the only difference is that this is here and this was here. What the fuck? Huh? What? Is this some weird caching issue? Also, hi, Crostan. I'm very confused right now, as you can probably tell. Okay, we're uploading. Yeah. Okay, I reckon there's some weird flipping caching thing going on, right? Because this exact same code, just with a different name here for this thingy, sounds correct in the example, but not here. I think it might be time. Wait, hold on. I haven't accidentally kept a talkie.h in the same project as the Arduino thing, have I? Oh, that'd be embarrassing. Arduino. Talkie benchmark. No, I have not. No, I have not! This is where we are. Talkie benchmark. This is it, right? With sanity check, but this is it, right? We're here, right? This is the same folder? Yeah, okay. Hi, Until You Ruined. Welcome. I'm gonna reload the Arduino because something fishy is going on here. Something fishy. This is bizarre. I haven't had this problem before. I have had the problem of it not reloading libraries, but I've not had the problem of it selectively reloading libraries for some open projects and not others. Okay, so let's recompile this. Compiling. Uploading. It works now! It's so quiet. Okay, amazing. Literally turning it off and back on actually fixed it. Oh my god. Actually, metaphorically. That wasn't literal. Fantastic. Where's the ID? Look for libs, path. The libraries folder here. I'm gonna re-put this one back and then reload the Arduino IDE. We're copying the UKified ones. And restarting Arduino again. In the hope that maybe one of the changes that I made actually did fix it a long time ago, but it never it never reloaded it. So we'll see if actually this fixes it. And also if it does work now, it should be louder because that's just one of the changes I made. But it shouldn't be clipping like crazy. Oh, hang on a second, I haven't got the Arduino plugged in. Oh, I just got it plugged in time. Okay, it's uploading. Okay, unfortunately it did not fix it. Sad. Fuck, I thought that was gonna be it. I thought that was gonna be it. I really thought I'd something. Picture adder. vector bit. So wait. Wait. Hang on. Is this a... Wait. Put the noise gate back on, sorry about that. Is this because I've declared some things that change, but... Like, I under what circumstances do you need to put stuff in a header file? I will never understand this in C. This is like one thing I'll never understand, apparently. Or C++. There's... Why is this public even? Why is this public? Like, your setup doesn't even exist anymore, so I don't know why that's still in there. That should not be in there anymore. Yeah, it's not in there, so we don't even need this in here. So, like, there's a bunch of little... Like, these are functions, right? These are functions. And these are variables. And the pointer there. So, like, do I need to put every single thing that I'm using into here for it to work properly? Like, do I need to redefine this inside here? Or declare this inside here? Is that the problem? Like, I don't want it to be public. It's fine being private. Is it private by default? This is an array, and these arrays are not in here, so I guess I don't need to put the array in here? Man, I will never understand this. Like, why are they choosing to put these things here? Is it because they're private by default? But you need to do that for functions, but you don't need to do it for variables? F, what? Do you mean this? Do you mean the stream has stopped? I wonder, does anyone else still see the stream? My OBS is uploading. Okay, nice, thank you. It did for a second? Oh, okay. Boring. Did it for anyone else? This makes such little sense to me. This Notepad? It is currently Notepad, yeah. Because if I want to edit it on the Arduino editor thingy, then it copies the file, and I don't want to do that. Yeah, but only for 1 to 2 sec. Okay, I see. Okay, I don't understand why. Why they're putting these... Is that the case with C++, that if you have a class, you do need to put functions in the H file, but you don't need to put variables, and the variables are private by default? Is that the case? Because that would explain why they've only put these ones that they want to be public in here. Otherwise, who knows? Maybe the reason it wasn't working is because these things weren't here. Am I a hacker? Absolutely not. Hi Natty, welcome. Well, maybe in like a... probably not even in the original sense of the word hacker, to be honest. Comment out the line private. Why? I want these to be private. Thank you very much for the follow. That's what a hacker would say? Man, you got me. Do you also do this for a living? I mean, embedded stuff. I do not. I've never done any programming stuff for a living. Also, hi Dex Physics. Welcome. Just make it public while debugging. Is there a reason to do that? Like, I'm not going to be accessing them from anywhere else. Does this need to have been declared? No, because this is working fine. We are decoding the audio just fine. These are still set up. What is it? What is the difference? It's not just that pulse width modulation is messed up, because the values, we saw the values that it's trying to send out over PWM, and they're wrong. I'm gonna take a closer look between the original and my version now. even though like my Windows version, it works on Windows, it doesn't work on here, so screw it. Uni students in shambles. Who else but a hacker touch machine code? This isn't machine code. I'm not touching machine code. I'm not even doing assembly at the moment, although I have done it. I'm not doing machine code. Are you putting values into class variables from the global scope? No, absolutely not. I don't know why those things are marked as public either. That's not a thing that I'm wanting to do. Am I putting values into class variables from the global scope? I guess I don't even know what you mean. I'm not trying to do anything like that. Do I need to put these in public like the other things were put in? I can try putting them in public. Talkie.h. Hello, Windows. Thank you. Talkie.h. Let's try putting them in here. Because they put these in public for some reason. Wait, this is a timer thing though. This is a timer interrupt. So is that like not running from within the class? Wait, that could be it, right? Or not? Who knows? Let's just try to do this. Let's try to declare everything that's used inside the timer callback. Cursynth period, energy, and cursynth. Okay, all of this stuff. Wait. Oh shit! Oh shit! All of these things are no longer static. So... and they're being changed from inside a timer interrupt. Whoopsie. 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 Let's mark them as volatile. Do I have to put volatile for every single thing? Or do I need to only put it for the first one? I'll put it for all of them just in case. This could very, very well explain it. This could very, 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 very well explain it. This is something that is very different between the original and this. Because, yeah, these used to be statically defined inside the timer callback. But now, I'll declare it inside the timer callback then. Or ISR, I guess. I don't really know the difference between whatever. This, and this. Okay, that may well have been the problem. These are not being modified from within the callbacks, though, but these are. None of these are. None of these are. Okay. That might have been it. And this is not from within the callback either. But I might change some of these things to eventually be within the callback so that it doesn't have to be blocking. Anyway, let's see if that works. If it doesn't, I'll try putting them in here as well. But I don't think they need to be in there. But let's try it anyway. I think the reason will have been because I was not declaring these volatile. That is a huge mistake to have made. So those values will have been trying to be written to, and they weren't marked as volatile. Okay, let's see. Was that the reason though? That's the real question. Compiling, uploading. Fuck! Okay, I don't actually trust it to be reloading the library though, because it definitely didn't last time, so. Let's close it and reopen it. And see if this time it does. Make sure I was modifying the correct file for a start. Yep, they're marked volatile now. Compiling. Uploading. No, it's the same. It's the same. I wonder if that is a problem, huh? Right, because the timer in a class. I guess I could still mark them as static. The only reason I need them to be declared outside there is because the only reason I wanted to have them declared outside there is because because I wanted to be able to reset stuff like this. But there shouldn't be a problem though, right? Hold on. Hold on. How was this done before? Original. Synth K3. Okay, yeah, that's done in there. Blah, 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 blah. Okay, yeah, and these are not modified. They're accessed, but they're not modified. Okay. Oh, actually... Yeah, no, they are modified now, aren't they? Well, not those values, but the current ones are. The ones marked as current. These ones are now modified from within here. See, I could change those to be static inside here instead. But... Sorry, inside wherever they're being used here. But I wouldn't have a way to force like the interpolation to like not happen on in some circumstances, which is what you're supposed to do in these circumstances. So I could change this to be done like that. We could try that. But we wouldn't be able to do these anymore. We could define these instead as being... Oh, but this... Ugh, these would also not get reset. Did the original use interrupt timer function? Yes, but the original I don't think modifies anything. I think nothing is volatile in the original. Like inside the timer interrupt, I don't think anything... Let's see. Volatile. Yeah, there's nothing. So the original is not modifying it inside the... Inside there. It's all static and stuff. I would have expected it to still be possible though. Because like, the address is still going to be correct, and if it's marked volatile, the compiler shouldn't be compiling it away. Right? We kind of just need a way to signal when the next frame is beginning, and then everything should just work. I mean, then everything should be convertible to be... you know, let me make a backup of this. Ukified. Let's make a backup of this in its current state. Ukified before static. And I'm gonna try to modify this to be entirely static now. Okay. So we're going to not have anything declared volatile. It's all gonna be inside the thingy. So we can just declare all of these now. So we shouldn't need any of these. So these, just as a sanity check, these were declared static inside the timer before, right? No, because they weren't ever modified before. That's the thing. They were never modified before. But now they are. Man, all that benchmarking I did. Down the drain. Because this code is going to be very different now. So we can just declare this and this as static. And these no longer need to be marked volatile. They are instead static inside this timer. I hope it's still going to be fast enough to run. if I'm able to get this to work. Okay, so they're all in there now. And this is very awkward doing this in Notepad now, I'm sure wasn't needing to. These also can be static inside there now. Then I just need like some signal to be external so that basically there's a way to reset some things sometimes from outside the timer thingy that the timer can look at to change its own static variables without needing to change anything external to the timer callback itself. If this is the reason why. If this is not the reason why, this is a huge amount of time I'm wasting right now, but we'll see. Because this is going to take a little while to change all this stuff over. Let's see. I'm going to zoom in a bit. I should have been zoomed in anyway, why was I not? Sorry. Okay, this is all static now. What a ridiculous number of static variables. I've never seen so many. Okay, so this is all being done inside here now, which is fine. This is all inside. This is all local. Since this is like local now, couldn't I? Oh no, hold on. I'll keep it as it is. Won't change it. So we're now free to change any of this now. This is fine. This is fine. This is fine. But in here, outside the callback thingy, down here, we can't do this anymore. So we need to like raise a flag, kind of, to say, hey, you need to not interpolate this time. This is a thing it's going to be checking like 8,000 times a second, which just sucks. So, let's call this, what do I want to do? What do I want to do here? What do I want to call this? Let's call it, do not interpolate. Or maybe jump to target. Skip to target, let's call it. Skip to target. In this case, we'll set it to true. And we're only going to need to set this once because we're going to... Oh, we can't manually set it to false though. Ah! Oh my god. Okay, this is the thing. Ugh, how do I do this? What I'm thinking of doing is having like a variable that I toggle inside the callback. I'm finding this really difficult to explain right now. I'm sorry. I'm just going to do a thing and see if it works. And try to maybe explain what I'm doing as I do it. Okay, we're just going to have this set to true there. We'll have a variable here called skip to target. At the global level, it's going to be a bool. Wait, what? Skip to target, which is going to be false by default. And we need to know if we're starting a new frame. So basically, if this is reset to 0, that's when we need to do something. So we're already doing a test to see if it is a multiple of 8, which 0 is. It's a multiple of 16 now, isn't it? No, it's a multiple of 8. So we might as well see... Put the check inside here, so we're not doing it all the time. If end sum of frame is exactly 0, so this means if a new frame is beginning now, possibly jump to target immediately. And we'll do that if skip to target is set. In that case, we'll do all this. Oh wow, it's the correct indentation. What the hell? Or is it? Yeah, it is. Perfect. Makes life easier. If I remember correctly, the interrupt function should be as short as possible. I know! But I've already been benchmarking and made sure that it was fast enough. But it might not be anymore. But this is how it is now. So we'll see. Thank you for the posture check, Stu. Oh my goodness, that was a good crack. I don't know if you heard it. Thank you for the pats as well. Okay, if this... so this should be like else. Then we do nothing else, I guess. Thank you for the hydration. I'll do that in a sec. Do we want to only be continuing if this is else? I guess I can just do this. I'm gonna take off these gloves. Why am I still typing with these gloves on? Oh my god, I'm such an idiot. I don't even have the webcam on right now. Kidneynt. I'll be stopping soon, don't worry. I actually don't need to save the kidneys yet. I will hydrate in a sec. Okay, so we're resetting that there. Wow, this feels so weird being able to feel my keyboard and mouse. It feels like there's so much texture to it. I haven't been... Ensemble frame. Ah, ensemble frame is us though. We're defining that. We're defining ensemble frame. So we also need a flag that says, how do I explain this? We can't change... we might not be able to change a value of a class if this is the reason for all this weird stuff happening. I might be going down like a rabbit hole here. A wild goose chase. But we might not be able to... So if this is the reason... If the reason for this weirdness is that we can't change a class variable from a timer interrupt, which I can't really believe that's a problem, but whatever. If it is, then we don't want to be changing anything from a timer interrupt. So what we'd do instead is we need to look to see if something has changed since the last time we saw it, and then we update our local static variable inside the timer callback. Yeah, that's basically it. So we could just have like a frame counter, I guess. Ind frame. Yeah, this is called a unique frame or something. Ind frame unique or something. I don't flipping know. Current, sure. What a weird name, I don't know. Anyway, that starts off as I guess we can make it a 0. And this is what will advance. Here, it doesn't matter when it wraps. We just want to see that it's changed. So we can't do this anymore. So instead of that, we mark that a new frame has happened. So mark that a new frame has happened. I actually have no idea how a timer might interact with something marked as private in a class. Interesting. Did I already try making it public? I can't remember if I did that or not. Okay, so let's see. Come on, double click, please. There we are. So, under some circumstances, we reset the sample of a frame. So, static, unit this, prev. And now, we can do this. If the current one is not equal to the previous one, then firstly, we'll update our knowledge of what the previous one is to be the current one. And here, we reset the insump of frame to be 0, and that's the way we reset the frame. And if this is 0, we also do this. So I might as well actually just do this inside here, now that we have that section. We don't need to be doing this at all. Okay. Hi Menons, I respect notepad programming. I don't want to actually be using it, but I was not expecting to be having to modify a whole bunch of stuff. So now it's just open in Notepad and I'm modifying it. And if I try to modify it in the Arduino IDE, it flipping makes a copy of the file, which is not what I want at all. Anyway, welcome in, welcome in. Welcome in, Minons. Also, hi, Nitrohard. Welcome, welcome. How are you? Head's hurting a little bit. Circuit works. The code doesn't. This is not what I was expecting at all. Alright, let's see if it works, I guess. Does it compile? Thank you for the pads. Which things am I trying to modify? Which things am I trying to modify? Oh, I still can't do this. Immediately reset synth state so it doesn't interpolate from a previous state. Cheese. So in this case, what I should be doing is saying skip to target equals true here. We don't need this anymore. Is that Ixia? That is Ixia! Hi, Ixia! Welcome, welcome. That's a lot of pats. Oh my goodness. Thank you. I'm not sure I deserve them right now. That can go away. Oh my god. The boop, boop, boop. The pads were going along with the beat of the music. We also don't need this. Mark the new frame has happened. Has begun, I guess. So target synth has been updated. Targets have been updated. Will that compile? Wonder if that'll compile. There's probably some bits I've forgotten to change. Let's see. Hope things are going well. Things are going confusingly. Hi, the evil hello there. Welcome, welcome. Error compiling. Okay, where's the error? Okay, where is it though? Interp was not declared. Ah, right. Okay, those are some other things that get reset when the new frame starts. Hold on. These things need to also be changed. So these are now done in the timer callback, which, as someone said earlier, should be as short as possible, but maybe it can't be right now. I don't know. Let's see. Anything else that I'm missing? Probably. Oh shit, it compiles. Okay, let's try to upload. Was not expecting that to compile. Yep, shush, you're compiling now. Fuck! I mean, the nice thing is that it sounds identical, so the problem was not that the things were not static and that it was changing things outside the timer callback. I mean, it's kind of good to know. So the problem is somewhere else, which means that the problem is probably such a stupid mistake that I've missed somewhere. Because it's not like a complicated thing like that anymore. Like, the complicated thing is not... It's not a complicated thing like it is trying to modify something that's outside the timer thingy. Also, really nice to know that it's the rest of it still works. Extra pitch accuracy. Yeah, this is a thing that I modified. I can put that back, I guess, but this should only be affecting pitch. These are things that I changed. I guess we can put it back. Sure, let's put it back. This won't fix it. But also, let me just hang on. Let me restart. There's a small chance it didn't reload, right? Even though it was checking it. We had that weirdness earlier where it didn't actually update, so... I've been burned once. I don't trust it anymore. Reload. Compile. And upload. My color theme? I don't know what my color theme is. This is just how the Arduino IDE looks. Okay, this is a different size. What? Oh, of course it's a different size because I disabled the extra pitch accuracy. Okay, but no, that wasn't the problem. I'm putting it back. Wait, why don't I ask the original ones? 20. Ah. It's not this silliness, is it? Because that was the thing that I changed. Is pin speaker like ever used here? Pin speaker's never used in here. Okay, so that's irrelevant. Why did I add a thing called pin speaker in here? I guess for use outside this library. In a weird way. Oh man, ugh, like, there's not much left. There's not much left to compare anymore. At this point. What is not original anymore? I mean, like, you know what? Let me just change these to Ukified after static before I modify them further, which I'm about to do. Spoiler. Also, hi French Monka. Are you sure the algorithm is working? Well, it seems to not be at the moment. That's the problem. I'm not sure why, because I checked the original. So what I'm gonna try doing is actually swapping large parts of the original algorithm back in and seeing when it magically works. I don't know why it's forcing interrupts to be enabled here inside the callback. This is really weird to me. I don't know why it's doing that. Like, I'm never turning off interrupts anywhere. Unless it's to allow this to repeatedly be called while it's already running or something, which seems really dodgy, but I don't really like that at all. Oh! Hold on! Wait, no, that wouldn't explain it either. That wouldn't explain it either. Never mind. Sorry, I should stop squeaking so loudly. I was thinking maybe it's doing that because the global interrupt thingy gets disabled when a thing begins, and then the one that's meant to be pulsing really fast at 62.5 GHz might be being blocked by this one that's running much slower because it takes a long time to process stuff, which could be messing up the waves that are being sent. But we still saw weird values being calculated for U0. You squeak as loud as you like. No, I shouldn't. It's gonna destroy my voice. Hi, Mewelfel. Welcome. I can tell it to do that, though. So at least we should get, like, you know, the correct PWN then. But aren't the values wrong? I thought we discovered that the values were wrong earlier. Am I crazy? Yes, but that's also irrelevant. That's like, I am serious and don't call me Shelly. I'm closing this. I'm closing this. I'm closing this. Because those things will work. Hey. Okay. Let's see. Compiling. Uploading. Okay, so that was not the problem. Which I'm quite glad about. That means we don't need this here, probably. Just in case, I'll leave it there. I'm doubting everything now. I'm doubting everything. I'm pressing X non-stop. Man, what am I missing? This is like, it's so close to working, but it's just like not quite. What am I missing? This feels like such a. I'm probably gonna end stream and realize, oh, it was that as well. It's gonna be so annoying. I mean, that's often how it is. That's not meant to be me boasting. Maybe I won't work it out this time. So we could try all this unoptimizing, seeing if that fixes it, even though it still works in the Windows version. I'm gonna keep on saying that every single time. Changing how the clamping is happening as well. Just gradually putting things back until something works, right? The X0 and X1. Not a bad way of doing it. Close your eyes and when you open them up, it'll magically work. they're closed, but you can't tell. Well, my eyes actually always look closed with this 2D avatar. Now they're open. I didn't believe that would have worked. Okay, so for that I'm gonna have to put these old magic values back in because, well, first of all they're different types, and then they're also bigger values to take advantage of those types. Alright. You can go back. So this is no longer even being used anymore, but whatever. Interpolation should still be being used, no? Ah, right, these variables are being renamed now, that's annoying. Ah! Okay, this will be too slow to interpolate though. But sure, let's just go back to where these things were being oh no, you know what, no, I'm gonna rename them back to cursynth. It's too annoying otherwise. Synth matching case becomes cursynth. Boop 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 boop. And boop, 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 boop. What was the last one I changed? Oh, that one. Okay. So this also won't quite work because I'm defining these to be since K1, K2. So this synth 1 and cursynth 1 and cursynth 2 should be 16T now, if this is to work. I think. Yeah, cause yeah, okay. Yep, cause yep. That explains it. Okay, let's see if it recomposes. 5910 bytes. I'm just looking for that because this will change. 5910 6110. Okay. Let's see. Uploading. Okay, I've left some code from something else. Oh, I think I know why that is. I know why that is. That is the pitch is just weird now. That's because I still have the code for doing the extra pitch accuracy in here, but I'm no longer taking this into account using this macro for the period thingies, so we're getting wrong pitch. But anyway, the problem is ignoring the pitch. It's still really distorted and clipping, even with this, which is interesting. What if we switch it back to this? I feel like I already did this though, but let's try it anyway. We do the next PWM there, and we set it there, and we make this static next PWM, so that we're not setting it immediately. I can't hope to understand why that would fix it if it does, but let's try it. Let's make sure the file size changes. 6110 it was. Getting ready to upload. 6110. Okay, it's changed. Okay, no, it's still doing the same thing. So that's not the problem. Gotta click your heel 3 times also. Maybe it's the clamp. The clamp is back to how it was now, and it's still the problem. Imagine your speaker was just broken slightly. Nah. That's kind of funny though. What is left? What is left at this point? What is actually left? Period count, where is period? Where is the period? How does the period? Oh, it reads from the chirp thing. And U10, and chirp is an integer, I guess, and U10 is an integer. 8-bit, right? U10. is in 16T actually. And the chirp. Hold on. Hold on. Did I change? Or was this something that should have always been this way? Hold on, hold on. Where's the chirp? The chirp's defined in a weird position in the original. Down here. Okay, the chirp is originally 8-bit here as well. And when it reads from chirp, it assigns it to... Oh, I see. If you could see my face now, you'd be seeing like shocked eyes for a moment and then being like confused eyes and then realizing and stuff, like as emotions are flitting across my face at the speed of light. But not actually. Chirp period times U and 16, shoved 8. And it was 32 in the original. So synth energy, have I redefined synth energy? Guess I should put these back as well. Synth energy was originally defined as UN16T. Synth energy. Ugh, but this works on Windows. Why would it not work on here? Sure, let's put it back though. Period was originally UN8. Synth energy was originally 16. So sure, let's make it 16. In 16. No, UN16T. Can't type even without the gloves on now. Nice. Imagine if header file. My brain inserts Phoenix Wright animations every time Yukia says, hold on. Objection! I could check that. Oh my god, everyone just said objection! Amazing. Amazing. Nice. I'm glad we can all share a brain cell together. That's pretty cool. Okay, let's recopy this bit. Let's copy this bit. From here to... here. Yes, this area. Which is not gonna look indented anymore, so it's gonna be a bit weird. Would have been faster to copy and paste the double space and... I wonder. Too late now. So this synth period is now named synth period. And synth energy is now named synth energy. We are matching case there, so I'm not messing up all of the already changed ones. So energy is still correct. Synth energy, blah 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 blah. Current synth, so target synth K1 are defined like that. Synth K1. Oh, they're taken from the K1 and K2 thing, aren't they? Yes, they're correct now. These... yeah, this will actually need changing back to 16T as well. And this will need changing back to 16T as well, actually. That would explain why these two were broken for a moment. On the last time. That is a reason why it might have been failing on the last thing, is what I'm trying to say. I can't even speak anymore. Let's see if that fixes it. Compiling. Oh, error. What the hell? What the hell? Error. Synth energy. Expected initializer before static. Wait, what? Oh, I think I forgot to put a semicolon somewhere by the look of that, probably. When I split it from one line to another line, that's the original. Where's my version? Yep. Semicolon. Mom said it's my turn next for the brain cell. Sure, you can have that. Okay, it's done. There it is.
Scratchbug. Decoding waveform. The Uke is hungry. Feed me.
It works. It finally works. Decoding away from Uke is hungry. Feed me. I could do. Okay, so why was that not working then? That's the real question. Was there a... Okay, hold on. Okay. Let's first start by changing these to int 8t again. Yeah, these ones. Yeah, that alone should be okay. Oh, I shouldn't actually. No, I shouldn't. Let's just do this one first. Okay. So these ones now should be different. So these are now 16, 16, and then you shoved 7 and 7. And then I changed the thing in the lookup table as well. Afterwards. Let's yoink those back. Just the values from here I care about. Int 8_t. Okay, these are sensible values, right? We're not trying to make these like outside the range of -127 to 128. I mean -128 to 127. That looks correct still. So now we change this to 8-bit as well. Synth K1. That's now 8-bit. That's also 8-bit because I just changed it. That's 8-bit. That's 8-bit. The value we use at the... Yeah, okay. Where's the value we use at the end? Goes into x0, u1, u0. We're doing the clamping. Okay, so we're... At the end we have a value that used to be like 8 times the size, so we used to have to shove it further, but now it's no longer 8 times the size, so we... Okay, let's see what happens. Compiling. It's the sound of me plugging in the USB. Okay, still works. Okay, so that one wasn't the problem. Okay, let's also change the energy. Let's change the energy back to being 8-bit from 16-bit. Oof, we'll get there eventually. So, energy, right, and put you back to 8-bit as well. Try restart the program. Actually, that's a good point. I probably should, shouldn't I? Let's make sure it still works. I should be a little sus when things are working. Okay. Uploading. Still works. Okay, good. What I was trying to look for is the compiled size changing. 6010 it currently is. So this changes back to 8-bit now. So since energy, we're gonna want to... No, the lookup table for energy is still okay, I think. This needs to be 8-bit. Synth energy. I'm like redoing all of the optimization thing that I originally did off stream, like on the Windows version that I, like turning it into a Windows version to make sure that it would work for the Arduino. That didn't really go according to plan, did it? Oof. Okay, so we add, that's interpolating. This needs changing now. So we used to be having to shove it to the right by 8, but we shouldn't need to do that anymore because the value is going to be smaller. And this should only now need to be... Well, how was that before, actually? How was that in my this version. Okay, we got 3 notepads. The left one's the original, the right one's what I'm currently working on. The middle one is what should have been working, but it wasn't. Where are we? Where's the energy bit? Here it is. So I did make it 16. Wait. Why is I still showing right by 8? No, why was that working on Windows? Oh! Wait. Current sense energy. Man, this is a little bit suspicious, actually. Energy is just an 8-bit number anyway. So actually this was still being shoved this way. Okay. Why was this being declared as defined as 16 bits, I wonder? Is it just so that it didn't have to be converted every time that it was accessed? Because it always wanted to be 32-bit, actually. So I still didn't explain why they were defining it as 16-bit. Current sense energy is only ever... I guess... No, it doesn't really make much sense, does it? It takes its value from an 8-bit integer. And we do a multiply here. That's basically it. Yeah, that's basically it. So I don't know why it was being defined as 16-bit, especially when it wants to be 32-bit here anyway. Okay, whatever. Let's just see. It's back to being 8-bit, but I'm keeping in their thing that does the 32-bit conversion, rather than changing it to what I changed it to, which was 16-bit. Because the reason I changed it to 16-bit is because this is an 8-bit number, and this is an 8-bit number. And you should be able to get the result of the worst case scenario of 255 times 255, which is like, you know, a bit less than 65535, right? And that fits in 16 bits. So that you shouldn't need 32-bit for that. Right? Basically what they're doing here is they're just taking a value here and they're wanting to... Effectively they're doing fixed point multiplication, kind of. Basically they want to multiply this by a value less than 1. So they multiply it by a value ranging from 0 to 255 instead, and then shove it right by 8. In other words, to divide it by 255. So like this shouldn't need to be 32-bit, surely. But anyway. 0xFE01 is U10 unsigned. U10 unsigned. U10 is signed. U10 is signed. It's also not static. Is that correct? Yeah, it is correct. U10 is unsigned. Sorry, U10 is signed. No. U10 is signed. I wonder if this value, current energy, does not go above 128. Energy. No, it does actually. It does go above that. Interesting. This is a little bit sussy, isn't it? Signed would be overflow then, wouldn't it? I don't know. The original code is this, and it just works. But maybe this line is the one that was not working for some reason on the Arduino. Let's find out. Save and upload. Plugging it in. Uploading. It still works. Also, we're back down to less than 6 kilobytes, which is nice. Let's try changing it to 16 and seeing if that was the reason. Is that how it was in this version as well? Yes. see. Okay, okay! So it might just have been this. It might just have been this. I don't understand why this works then in the Windows version, but not in the... Okay, let's go back to this version. Okay, let me just... And the only thing I'm going to change is this from 16 to 32 and see if that magically makes everything work. And if it does, I'll go back to before I made things static as well, because that's slightly more efficient, because I'm not doing loads of stuff in the timer. Or, yeah, the timer ISO will be slightly better. So, Unified, Synth energy is U32, or temp is U32, sure, whatever. That's a really weird name to call it. I don't normally make my backups screaming capital letters like this. I don't know why I started and now I'm stuck doing that, I guess. Okay, let's go back to this version. No, not before static. The after static. We'll take these. Did I make a backup right? Yes, I did. Okay, copy and paste. Let's get rid of all this. So, I think the only difference that was necessary was this. I don't understand why, because it wasn't necessary on Windows. Where was it? Where was it? After the interpolation. Here it is. So this, putting us back to 32. It's a bit annoying, there's a 32-bit multiplication, and it's not fast on an 8-bit microcontroller. But let's see. Uploading. That's it! It's correct now! Hold on. Let me press reset. It's not interpolating though. However, I've changed a bunch of weird shit that apparently I didn't need to change. So let's go back to this version before I made stuff. Let's go back to this version, an even older version, before I started trying to make things be static. I think I might have accidentally changed something, but not much. Let me just put this back. I'm not even going to put the noise gate back on yet. Hold on.
Jeez.
Nope. No cheese. U32. I've changed something to be static, I'm sure, somewhere. Or removed the volatileness. Okay, this is with things not marked as volatile as well, which probably should be. These probably should be marked as volatile here. Because they are being changed. Why? Why cheese? Hi, Stur15 and Bucky. And Dr. Dankenstein. Did I already say hi, Dr. Dankenstein? I read your messages, obviously, but...
Jeez.
Hi! I'm gonna do this. Okay. Let's see, does the compiled size change from 5964? Hopefully it'll be less. 5904. Nice. Oh my god, it's doing the interpolation! Holy crap, it's actually doing the interpolation, although it sounds a little bit weird, but it's doing it. Wow. Okay, super nice. So we can put this thingy where it was doing the volume boost thingy back as well, if it's not already, because it sounds quiet, so I expect it's not. Oh, it is. Oh. That is already volume boosted. Oh. Oh. It's kind of quiet. Maybe I'll make the speaker not face down into the desk and it'll sound louder. Let me try and turn it around without breaking things. Okay, the speaker is now not face down on my desk. I'm pressing reset and seeing if it's louder. I cannot believe that the entire reason it wasn't working was because of this. That this was 16 and it should have been 32. All that time. Holy crap. Oh my god. Wow. Okay. Well, it's working now. Which is pretty nice. We can also do an artificial volume boost. I'm gonna do a little volume boost. I know I haven't turned back on the noise gate now. I'm being a rebel. So I'm gonna purposely make it clip here. I'm gonna like purposely overdrive. Wait. Yeah. Yeah, no, I am. We're gonna say 63 and minus 64. And then we're actually gonna left shift to boost then. Left shift to boost as opposed to X to downs. Okay. Rabbit holes are fun. Yeah, it turns out the timer just works. At least if there's one instance of this thing running. One instance of talking. Maybe if there were two it wouldn't work, I don't know. Although it's marked volatile now, so it might. Okay, it's kind of loud. That's kind of loud. Oh no. Oh no, my transistors are warming up. Okay, interesting. Why did that... Oh! Because I'm fucking... Oh my god, I'm left shifting it after I've offset it. Nuke, please. Okay, let's try that again. Try it one more time. It was meant to be like a little bit clipping, but not that horribly. Uploading? Nice! Okay, that is super nice. These transistors are warm though. They're a little bit warm. I think this is a hideously, horrifically inefficient circuit, and maybe I should just like actually use an amplifier chip instead of, you know, fucking around with transistors. Okay, that is really cool. And that is like specifically, like explicitly trying to make it clip to boost the volume, and it just doesn't sound that bad. How much can I do this, and like how much can I get away with? You can't keep getting away with this. Can I like make it even louder and it just won't sound too bad? Because like apparently just... Oh, I wonder if they're getting hot because the low pass filter is not filtering out the... I bet that's it. I bet they're getting hot because the low pass filter is not filtering out the 62 kilohertz very well. Maybe if I try to filter it out more. Let's just swap out for a different capacitor. So now you can speed it up in the sound editor. I guess I could also just make the sample rate be defined as higher. Although, is this even being used anywhere? This is being defined here, but I don't think FS is actually being used anywhere. Oh, it is. It is. Never mind. It is. Although this is just going to make it sound more baby-ish. The pitch is still going to play, the speed is still going to play at this, I can't fucking speak. The speed is still going to play at the same speed, which is actually probably the best possible thing. So if we wanted this to sound like a little cuter, we could run it just a little above 8.5 kilohertz. This is also going to be double the loudness. If I remember to left shift by 2, I did. Let's see. Oh. Hold on. Let's see. Uploading. There, it's a bit higher pitched. Thank you very much for the follow, Slime Molder. I actually think that sounded alright. The funny thing is now, to make it louder, we're actually shaving bits. Okay, this transistor is starting to get kind of burning hot. I'm gonna unplug this. I'm slightly worried. Alright, that's enough. This transistor has been good. I need to give it a rest and maybe like try to work on the filtering a bit more. They don't have a 62 kilohertz. They do, but they're switching a coil, so there's, you know, There's like some inductance and stuff probably making this a bit worse and stuff, possibly. I'm not sure. That's what I was worried about. That's why I wanted to set up a simulation. Anyway, so Bucky, it's saying, at the beginning it's saying snail 2, as in like uke. I think it's part of a sound that I played saying uke snail 2. This was training data for the ask along uke voice, the redeem voice. The redeem's disabled right now. And thank you for the hydration one, Oxen. And wait, did I ever do the hydration earlier when I said I would? And then didn't for a little while? Free space heater? No. Oh, hey, I just found the other sharp bit on the longy bottle. My finger found it. Okay, I'm chopping it off now. Not my finger, the sharp bit of plastic.
Hey!
Lactose-filled dairy product.
It's fine, it needs to be chopped. Hold on, I'll explain the rest of what it's saying when this effect wears off, Bucky. The uke is suddenly vibrating? Is she? Is she? I don't feel it. Hold on. Let me just say what she's saying. She's saying...
Snail 2.
And then she's saying...
Slow, you go.
Let me play the actual original speech that this was converted from. Which is just a small extract. It is... Is it this one? No. This one.
Snail 2.
Oh, this is after the sample
Rate's
rate.
been changed.
Snail 2. Slow, you go. Slow, nyan, 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 nyan.
There's a bit of a problem with the pitch tracking in the converted version. I mean, that's just the encoder that's had a problem. I don't know why it lost track of the pitch. How did it possibly think that the pitch dropped there? I don't know how it got confused with the pitch there. That sounds really stable in the original. I actually held that pitch pretty well. It suddenly sounds much better than before. I don't think have I played that before? I'm not sure. That's the original. That's not encoded. That's just muffled though, because because it is. Okay, maybe I will remove this much overdriving, because that was making the things clip on purpose to boost volume. Shoving left by 1. Okay, this works. This is really cool. I'm actually going to probe the output now that it's working. I want to see how visible the ripple is. The 62 kilohertz ripple. Let's see. It's probing time. Did you find the problem? Was it interrupt scoping? It was not. I did find the problem. The problem was... It's so silly. The problem was this. This said 16 before. Now it's 32. Even though 16 works in the Windows version, for some reason it doesn't on the Arduino. I don't know why. I really don't know why. Probe my... Yep! Don't mind if I do! Hold on. Let me turn on things. You can go smaller now. The star of the show is now... Wait, why is it not... Oh. The star of the show is now this stuff. Okay, so... And I have put the speaker back face down. So if we just probe there... Will that stay in? Yeah, it will. Okay. Let's plug it in again. This is gonna look like clipping because, it's clipping because I boosted the volume a lot, remember? Let's zoom out a bit and plug it in. I haven't re-uploaded this, so... Holy shit! That is so much 62 kilohertz. Can I stop this before it goes off? Oh, fuck. Never mind, I couldn't. That is an insane amount of 62 kilohertz. Why is this so much? It's almost like there's no low pass filter at all. Wait, have I like connected the speaker wrongly? Hold on. No, I think that's correct. Yeah, so this capacitor here should be the one that's doing the high pass filtering, basically blocking DC. And this one here, that's in parallel with the output. Huh, so I think I might just need a higher value resistor. I think this resistor here might just need to be a higher value. Sorry, this one, this one, get out of the way. This one, the vertical one. Because basically, I think it's discharging the capacitor too quickly. If I bring back up the circuit simulation. I think what I need to change... By the way, that was not me who saw that. Well, I mean, I did see it, but then someone said, like, you know, something that made me think, wait, or said something like, are you sure, or something like that. I don't remember what they actually said. Wouldn't it overflow or something? Anyway, so this resistor here, I might need to increase this. Let's try increasing that to... Let's just randomly go with 100 ohms out of nowhere. Which is massively reduced current to... Looks like 33 milliamps peak now. But this waveform is going to be much lower now, right? Yeah, this waveform now looks much lower. But, you know, maybe it's not burning up my transistors anymore. It's not actually burning them up. I'm exaggerating, but it is making them warm. Hot even when I run that last one. Okay, 100 ohms, 100 ohms, 100 ohms, 100 ohms. I need to be stopping streaming very soon, but let's just try this. We've come this far now, so you know, it'd be a shame to not go way too far and then, you know, anyway. Hold on. Yeah, I don't understand why that needs to be 32-bit and it doesn't on Windows. I'm gonna keep on saying that, man. I don't get it. I might play around with that a bit off stream and see if I can find a way to make it be 16-bit. You know, by changing other things as well. Okay, I gotta chop off these legs a bit to keep it short enough to fit underneath the other resistors. Okay. Now let's remove... I'm going to temporarily pull that... Hang on, wait, where's my mic? There it is. I'm going to temporarily pull this out. And... remove... this. This is in the 18 row, right? Yeah. Have I gotten tracking for the MCU? Oh, like delivery? I'm hoping it arrives tomorrow. I'm thinking it's apparently will arrive tomorrow, but I don't really believe it until it arrives. I'm a little jaded. I just almost dropped that resistor inside my keyboard. Man, this would be so much less annoying to do if I weren't wearing gloves and I could feel things. But let's try it anyway. No, it's not gonna work. I can already tell that I won't be able to feel it. I know I'm using cutters as pliers, and I know it's silly, but... Okay, I did it. Come on, get in! Ah! I said I did it! Why are you not going in? Please, go in! Please! Go in! Ah! Now I've bent it! God damn it. Why isn't it going to go in there? It's weird. I literally just had something in there. Okay, what the fuck? Why are you refusing to go in? What is this? What is this? I swear. Man. Are the adapters coming with that too? No, they're not. They're separate. I don't know when they're coming. Okay, it went in this time. Wait. The other side. Okay, there we are. Wait. Why? This just went in first time with the other resistor. Why do you have to be such an awkward one? I swear. Okay, it's in. It's in. It's in. I hope it has proper connections and it's not shorting out the other things currently. That's for sure. I'll just pull this aside anyway. Okay. Thank you for the pads. Sorry, it's me moving the mic back. Now that my head is no longer down there. But that's also what... No, why would she say that? I don't know. Alright, I was about to press the upload button, but I don't need to press the upload button because I didn't change any code. Let's, see. Hey, nothing. That's worrying? What the... Oh? What the fuck? Oh, I didn't reconnect the ground wire. I'm an idiot. There we are. Okay, there it is. It's very quiet now. I'm probing it. Oh god. There's still so much coming through! Why is there so much coming through? I don't want to hear any of this. Wait, is this actually what I think it is? Yeah, it is. And funnily, it's been like DC... Wait, is this 62... Is this 62 kilohertz? Let's have a look. Let's get some measuring out here. Frequency, but it's on the wrong channel. Let's clear that. Clear, and then we'll add frequency. Frick. Zip, 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 zip. Frick on channel 1. 125 kilohertz, which is double 62.5. It's probably measuring it weirdly because these pulses look really weird. Interesting, interesting. I don't know why that's leaking through so much. That's really weird. I don't know why it's leaking through so much. Yeah. Aren't one supposed to use a tiny cap on the speaker? Why? I could also use a bigger capacitor for this one to try to muffle it more and let less through. I mean, it doesn't sound muffled at all at the moment, so I could go for a higher value. Yeah, let's try it. Let's try it. Oh, I should probably have felt the transistors to see if they're getting warm, but I expect they're not because they're not really doing much anymore because it's so quiet. Because the resistor is bigger. Let's remove this one. This is the 10 microfarad one. Yeah, this one. This one. My brain doesn't like me. For half a second I thought I could smell gasoline, and that half a second of a half smell gave me enough panic to actually go around and check that I am indeed not smelling gasoline. I mean, at least you're checking, right? Could have been a bad thing. Thankfully it wasn't. Okay, I'm gonna use a 10 times bigger one. Or 9 times bigger, actually. 47 microfarads. Oh, hang on a second, I'm in the wrong section. Where's the 100? Where's the 100? Where's the 100? Come on, come on, where are you? What are you? I need to drop the capacitor inside my keyboard that time. Okay, here we are. 100. Peak. Ah! I'm dropping capacitors everywhere. Help. Okay, let's use this. I'm gonna snip the lengths off because one is so drastically longer than the other. I mean, that's how it's meant to be, obviously, but it's no good for a breadboard. Okay. Let's plug it in. Let's plug it in. Oops, sorry. So this way around. Negative to ground. Pun not intended. Hang on, have I got it in the right hole? It's going to 18, 19. Yeah, okay, that looks like it's correct. Let's plug it in. Should sound roughly the same, maybe slightly more muffled. Okay, I still hear. Oh, quiet now! Holy shit! Now, if I probe the output, looks like this. Oh, it's help! It's still there. It's like I'm keeping everything I don't want to keep, and I'm keeping nothing of what I do want to keep. It's becoming so quiet now. You can barely even see the signal on there! What the fuck? Why is it draining so quickly, I wonder? Is it just, like, inevitable because of how low resistance the speaker is? Because, like, this is keeping it... I wonder. Huh. I wonder. Would adding a resistor in the line... No, it wouldn't, because it'd still be discharging the capacitor.
Cheese.
I don't know. I'm kind of lost. I'm not quite sure how to make this any better, actually. Why cheese? I hate that my brain made me think I was spelling something. You have a turbo sensor smell. That's interesting. Very occasionally I smell like a random nice thing that doesn't actually exist. Which is kind of nice, actually. Hi, Christopher. Welcome, welcome. Yes, white cheese is what I'm asking. Yes. No answer though. Shaking my head, my head. My head is shaken. Shook, one could say. It'd be a bit silly to say that, but that's the thing I could do. Alright, okay, I don't really know why this is... yeah, I guess what I'd really want would be the low-pass filter on this side, but is that actually gonna work if I put a low-pass filter on this side? With transistors, I guess it will. I don't know if it will with MOSFETs though, because, you know, something. Okay, so if I wanted to low pass the input to the transistors, I would want to put this capacitor between ground and the input, right? I'm pretty sure that's right. Alright, let's design that first. Let's simulate that. Let's do that. Let's slide these off to the side. You now come over here. Blech. You now come over here. And yeah, you connect down to ground, which I'm just gonna do with a line. Actually, that looks weird. Let's not do it that way. Let's do it from here. What the? Oh god, right, this is going to be putting insane load. Oh shit, right, of course. This is going to be putting crazy load on this. Right, of course it is. Because it's charging this as quickly as it possibly can now. That's not good. Man, I'm glad I simulated that before just doing it like an idiot. Yeah, we're gonna want to limit that. Yeah. I feel like this is something I'm going to want to look into. Also, I really, really think this is... I should just, you know, be using an actual amplifier chip. At this point, I really think I should just be using an amplifier thingy. We're limiting it now, but like... We're not, you know, it's not smoothing much anymore, is it? Yeah, I don't know. I should probably just use use a flipping, basically. Yep. Amplifier thingy and stop trying to do this stuff myself, because I apparently have no clue what I'm doing. A DAC and an op-amp. I can't use a DAC. I can't use a DAC. I don't have enough... I can't either be clocking out data fast enough, basically, to this, or, and I don't have enough pins available to do a resistor ladder. A resistor ladder would be pretty good, actually. I guess we could just make it 6-bit. We don't have to make it 8-bit. I might have enough pins for, like, less than 8-bit. Then we could just do a resistor ladder. That'd be pretty neat, actually. Like the R2R thing. I think is what it's called. I've done that once in the past. That worked very nicely. Also, it'd be less strain on the CPU because, you know, we wouldn't have this timer triggering 62,500 times a second anymore. The resistor ladder is pretty smexy. It requires so many pins, though. That's the problem. That's the problem. Wait. Oh yeah, right. I guess we could just use a shift register and clock them out over there, but then there's like so much more overhead of like the toggling a clock pin and stuff. I'm not going to do this over SPI because I'm really needing to use SPI for the LCD, and well, I guess I could do a chip select, but man, I don't know. This is getting so much more than I thought it would. Okay, let's exit this for now. We're done. That's gonna be the end for this stream. It's getting late, and I'm getting hungry, and my room is hot and needs to cool down. That's gonna say getting hot. Thank you for the hydration, Stu. I'll look into seeing how many pins I have. Maybe 6-bit is okay, because I'm currently doing 6-bit audio since I'm shifting this 2 bits to the left. Oh, did I change it to 1 again? Did I change it back to 1? I think I changed it back to 1. So it needs 7 bits, I guess. Sorry. Checking the code still. Where was I? This is the version we're editing, right? It is now. I'm holding the Nyan juice in my hand right now. No, I was shoving them left by 1, okay. So it's still a 7-bit range. Alright. Alright. It's pretty hot, they say. Hope you can find some cool... Thank you. The only cool I'll be able to find is outside, and if it's not there, then... bleh, is the sound I'll make as I die. Would you like to hear the scope turn off? You're gonna hear it now, whether you want to or not. Unless you, like, mute or something. Also, hi Galactic! Welcome. Hold on. I can't really get the... Oh, I can. Hold on. Here it is. Why is the music not pausing? I've pressed pause twice. Okay, there we go. I'm pressing the power button now. Boop! And then there was silence. But not really silence. Bye! I just wanted to wave. There we are. My mic is now facing away from me. Please come back. There you are. Please don't leave me. We need to budget to get you a tent. Oh my god, no, please. I wanna be out with the spiders. No. Posture checking as well, Stu. Yeah. I will save the knees. Okay, okie dokie. even. Alright, who can I pass you on to? So, alright, so next steps will be, maybe to try to work out how many pins I need. Which ones are not being used by, like, the SPI port or something, so I can just, like, send them out over that thingy. If there are 7 pins is a lot of pins on a chip that's only got 20 pins to begin with. And that's, you know, including ground and power. I don't know if I can dedicate 7 to that. Otherwise, just like a, you know, a low-pass filter into an amp, which I've done before and I know works. I guess is what I want to do. Alright, I'm gonna pass you on to Linted. Finally, for once, I can pass you on to Linted! Fuck yeah! Linted is actually working on a kind of a similar thing. But, like, a very different twist on it. Imagine a Tamagotchi-style thing. But instead, it's running on an e-cig that has an LCD, and the creature in it is not happy or cute, and it's smoking. Yeah, I'm pretty sure it was something like that he's working on. But anyway, he's also making it like an electronic thing. It's just kind of a real coincidence that we stumbled upon a similar project, but like from completely different angles and stuff. So he's like actually trying to modify, or, you know, modify an existing thing, like, you know, hack kind of thing. There are birds out there to catch spiders. They're wriggled and tickled inside her. What? That doesn't sound nice. What? Now I know it's worse than not knowing anything about what I am seeing, knowing half of it. I mean, I know everything, it makes sense, but I don't know any of the details. I was imagining a long uke wriggling for a second. That's why I continued to read that very cursed message, Liquid. Cheers for the stream. Hope it cools down a bit. Thank you. Oh my god, we've broken 30. Wait, is there heat haze? I'm actually not seeing heat haze. Hang on. What is the temperature? Where is the temperature? There should be a tiny bit of heat haze, but I'm not seeing it. Has my heat haze broken? Oh, there it is. There it is. It just kicked in. Interesting. It's very subtle at the moment. It gets really intense sometimes when the temperature gets higher. It fades in between 30 and 40 degrees. Alright. I'm gonna slide over here, and I'll probably experiment a little bit with, I don't really want to make an op-amp drive a speaker that feels like abuse. I'm not sure I have an op-amp that's strong enough, but I might have like an L... whatever it was. The amplifier. Anyway, there's where we're going. We're going to Linted. Thank you very much for the stream. Sorry, shit. I mean, thank you very much for being here. I just read thanks for stream, Bucky. Oh, god damn it. You made me thank myself. How dare you? I am only allowed to self-deprecate. I'm not allowed to self-replicate. Anyway, raid message. Raid message is Long Uke has blessed this stream. There you go. If you have access to the emote, then feel free to use it like this. I'm gonna use this one. Wait, where's the tail? Where's the tail? Here it is. Da-da! There's the message. If you don't have access to the emote, feel free to not use it, or use just the normal worm emoji. You're welcome for the stream. God damn it. You're gonna play Trackmania more? I'm mainly here for that. Maybe at some point. Well, I'm sure definitely at some point. Anyway, thank you for being here. I'm gonna probably play around with this circuit a little bit, and sometime I'll stream, not right now because it's far too noisy and people are gonna be trying to sleep. Okay, bye. I'm gonna save the kidneys and eat.